Yes, good morning, guys, to all of you. I welcome you all on this wonderful platform that is BYJU'S exam prep. So, guys, this is the second session for engineering mathematics. If you remember, in the first session, we have seen differential equations. And today we are going to see the matrix algebra, or you can say linear algebra. In the first session, we have seen just wait, guys. And today, yes, please tell me, am I properly audible, visible? Shall we start the session? Yes, Lemon. Mir, good morning. Faninder, good morning. Sai, good morning. So guys, if you remember in the last class, we have done differential equations. And today we are going to see the matrix or linear algebra. And from here, a 2-mark question is coming for surely it's coming for every paper, whether you are from mechanical, civil, ECEE or any branch. Yes, Utkarsh, good morning. Ashray, good morning. Ginu Singh Thakur, good morning. So do like and share the session. Mayank, yes, good morning. Anjan, good morning. Prince, good morning. So guys, all these topics when we are talking about in engineering mathematics, matrix is going to be important for all the papers, and every year one question is coming from that. Okay. Yes, Dar Arsalan, good morning, dear. So we are starting the session now, and this is some detail about myself. And guys, yes, Ronaldo, good morning. This is the Telegram channel Mechanical by Dheeraj Sardana, where I am sharing with you some practice questions as well. You remember that? You know that. Saurabh, good morning, bhai. So guys, now some important things I would like to tell you that on 28th of January, by appearing into this scholarship test between this time, you can get up to 90% scholarship for GATE preparation program for GATE 2025. Okay. So guys, and next thing is today there is a workshop of if any of you is preparing for GATE 25 or your junior is preparing for GATE 25, you can inform him that today there is a free workshop where I will be telling you about how to secure the single digit rank in GATE 25. At 7:30 p.m. would be the timing, and this would be on BYJU'S exam prep app. Shreyas, good morning, bhai. And guys, before we go further, this is the routine, this is the schedule for formula revision series. So today is 24th January. Today environment session would be there at 8:30 p.m. And for mechanical, today there will be thermodynamics. Okay, today will be thermodynamics at 8:30 p.m. Okay, so now we are moving further, guys, and this is about the schedule for engineering mathematics and aptitude. So you know that today we have switched this topic here. The reason for that is on 26th of January there is a separate plan. On 26th of January on BYJU'S exam prep app, as we have as we have Republic Day, so we are going to have a session on app where we would be having the practice of 75 questions on aptitude and mathematics. So that is why on that day we will be meeting at BYJU'S exam prep app. Okay, so moving further, this is about the civil versus mechanical war going on app at 4:30 p.m. Okay, so today we'll be bending and shear stress. Today I will be meeting you at 4:30 p.m. So guys, now Bhanu Prakash, good morning. Adarsh, good morning. Abhi, good morning. Yes, so now guys, we are moving further. So first of all, I would like to tell you that what are the various topics from which the questions will be coming in this chapter. So the first thing we are going to discuss is determinant. Second is matrices. Third would be the system of equation. And fourth will be eigenvalues and eigenvector. So yes, Ashray, for 26 January timing you will get on my Telegram channel. It would be in 2 parts. Morning will be aptitude because it will be in the form of a quiz. Okay, so that you can evaluate yourself. Mathematics part would be in the evening. So timing would be, you would be getting on Telegram channel. Okay. Sanjay, good morning, bhai. So I would like to tell you guys, these are the 4 topics we are going to see: determinants, matrices, system of equation, eigenvalues and eigenvectors. Good morning, Vinay. So these are the 4 topics we will go ahead, and we will be starting with the determinants, and then we will be going to the matrices, then system of equation. Here most important thing is the system of equation. Okay, but you may be thinking, sir, then why we are studying all other things? Yes, rank will be the part of this session only. So why we are studying all this? Because without understanding these things, we cannot reach to those things. Okay, so we need to understand everything. Okay, calculus will be coming. Don't worry, Arun. Calculus would be coming, and that would be coming in 2 parts so that we can complete it. Because in the last days, we will try to keep 2 sessions. Maths and FT together would be there on the same day. Okay, so we will plan like that. Everything would be covered. Okay, So now guys, we are starting when we are talking about this first topic, that is determinant. First of all, you need to understand what is the need of matrix. Like if you know we are having some equations, let us say a11x1 plus a12x2 plus a13x3, a13x3 is equals to b1. Let us say we have this equation. We have another equation a21x1 plus a22x2 plus a23x3 and it is equals to b2. And similarly, let us say we are having a31x1, then we are having a32x2, then we are going to have a33x3 and that is going to be equals to b3. If we are having these three linear equations, why linear equation? Because the power of x1, x2, x3 is all 1. So if we have these three equations, you know that we are generally solving the equation and finding out the solutions very easily. But the point is, as the equations are 2, variables are 2, it is very easy to solve. When we are having 3, it is slightly calculative. As the number of variables would be changing, number of equations would be changing, it would become difficult to calculate. Okay, so we can use the matrices and determinant to solve this by writing it in terms of some matrices. Like we can write the system of equation like this: a11, a12, a13, then we have a21, a22, then we have a23, then we have a31, a32, a33. You can see we are writing all the coefficient in one matrix. Then here we can write x1, x2, x3, x1, x2, x3, and here we can write this as b1, b2, b3. So we can also represent the system of equation like this. So when the number of equations are increasing, then my dear, it is always going to be easier with the help of the matrices we can go. You may be thinking, sir, if we are doing manually, what is the difference whether we are using matrices or doing by system of equation normally? So the point is, actually we are working for them on the softwares, and softwares are following those things. But as we are learning it manually, so for that reason we are keeping less equations only, and we would be doing with the way of matrices. Good morning Malesh, good morning Kunal, good morning Rohit. Yes, so guys, that is why in the softwares, whenever the things are going, it is going to be very, very less time taking, you know. So the point is how we are showing the determinant. So when we are talking about determinant, first thing you need to understand that every determinant is going to be a square. Like matrix can be rectangular, matrix can be square. What is the meaning of rectangular? As you know, if you are going to see the back slide, you can see there is some row. This is row number 1, row number 2, row number 3. Column number 1, column number 2, column number 3. If you can see here, number of rows and number of columns are equal. Yes, Rocky, good morning. If number of rows, number of columns are equal, we call it as a square matrix. And if number of rows and number of columns are not equal, we call it as rectangular matrix. Okay, this is the difference. So guys, now whenever we are talking about determinant, so every determinant has to be square in nature. Matrix may be rectangular, matrix may be square, but determinant is always a square. So like, let us see, if I want to write the determinant of previous matrix, I would be writing a11, a12, a13. Then I would be writing a21, a22, a23. Then I would be writing a31, a32, a33, a32, a33. Okay. Now, my dear, the very first question, as I said, I would be going from basic to advanced. Divyansh, good morning. First thing I would like to tell you here, कि whenever you are having some determinant given to you or matrix given to you, whenever you are going to expand it, the very first thing I would like to tell you, कि while expansion, the number of terms which will be coming, that is nothing but is equals to n factorial. Like if I am going to have a 2 by 2, let us say a1, a2, b1, b2. You know, when you will be expanding it, how the answer will be coming. Multiply this with this, a1, b2 minus a2, b1. So you can see this is a 2 cross 2 matrix. Okay. So you can see how many number of terms? 2. You can say 2 factorial. Similarly, if you are going to have 3 by 3 matrix. Similarly, if you are going to have 3 by 3 matrix, let us say A, B, C, D, E, F, then G, H, I. Let us say you have like this. When you would be expanding this, you would be getting, let us say A. You know how to expand the matrix. First of all, plus A, you would be writing this. This is going to be EI minus FH. Then you know minus will be coming alternatively B. Then you know what we will be writing, DIGF. DIGF. Then you know once again plus will be coming with C. Yes, then you would be writing what? It is going to be It is going to be DHGE, DHGE, DHGE. If you see total number of terms, it is going to be 1, 2, 3, 4, 5, 6. You can say it is coming out to be 3 factorial. So the first question which can be there, yes, Rajkumar, good morning. Calculus आज नहीं होगी. Today we are going to do matrices, guys. Okay, calculus आज नहीं होगी. Today we will see matrices, and don't worry, every topic we will be covering. Don't worry about that. Okay. So we have changed the plan because on 26th of January we are having a practice session on app, and that is going to be, as 26th January is there, you know that. So we are going to have that special day with 75 questions on aptitude and maths together. Okay. So on app you would also get the quiz format. So you would be looking at how many marks you are getting. Okay. So that is going to give you a practice session. So everybody is clear. Good morning, Dhanesh. Everybody is clear that the number of terms which will be coming here is going to be n factorial. So this was the first thing I need to tell you. Okay. Now, my dear, we are going to see some types of matrices and determinant. Matrices आज complete हो जाएगा, बिल्कुल पृथ्वी आज complete हो जाएगा. Do like and share the session, guys. Today we will be completing this chapter matrices. Now we are going to have the diagonal determinant. So when we are talking about the diagonal determinant, so this is the determinant in which, like, you are writing first of all the diagonal elements. I would like to tell you here, in a matrix, this diagonal is said to be the principal diagonal. This diagonal is said to be the principal diagonal. This is said to be the principal diagonal. This is said to be the principal diagonal. So my dear, whenever we are talking about the diagonal matrix, whenever we are talking about the diagonal matrix, it is a matrix in which the principal diagonal elements D1, D2, D3, all will not be zero. At least one out of these three will be non-zero, and all other elements are going to be zero. The same is going to be the definition when you will be writing it in a form of diagonal matrix. But the only feel is that when we are talking about the matrix and determinant, you know, determinant we are using as a tool to calculate the things. So here all D1, D2, D3 should not be zero. Otherwise, all other elements other than principal diagonal element must be zero. Then we will be calling such matrix as diagonal. Uday Ravan, good morning, dear. So can we go faster in this part? Yes, we are having upper triangular or lower triangular matrix. So when we are talking about upper triangular and lower triangular, you know that upper triangular element are, let us say, A, B, C, D, E, F, when we are going to write like that. So this A, B, C, D, E, F, this is said to be the upper triangle. All these three elements, all these 1, 2, 3, 5, 4, 5, 6 elements, out of 6 at least one should be non-zero, and all other elements should be zero. Then you will be calling it as upper triangular matrix. Or when we are talking about the lower triangular matrix, then you would be writing like A, B, C, D, E, F, and other should be zero, like that. So guys, if all the upper triangular elements, out of them A, B, C, D, E, F, सभी zero नहीं होने चाहिए. इनमें से अगर एक भी non-zero है, we will be calling it as upper triangular matrix. And this is lower triangular matrix, or we are writing in the form of determinant, so you can write determinant as well. Is it clear for everyone? Yes, 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 yes. सर आज के सेशन के बाद, हाँ, आज के सेशन के बाद मैट्रिक्स के सारे क्वेश्चन बन जाएंगे, बिल्कुल बन जाएंगे. तभी तो पढ़ रहे हैं भाई, नहीं तो पढ़ क्यों रहे हैं. अनुराज, गुड मॉर्निंग. Okay, so guys, after upper and lower triangular matrix, we are going ahead. We are going to see now, मुद्दे की बात पे आ जाते हैं. That when we are talking about the calculation of 3 cross 3 determinant, because 99% chances are you would be getting from 3 cross 3 determinant. So if you are going to get 3 cross 3 determinant, it would always be calculative to whenever we are going for expansion. So is there any shortcut? Yes, I am going for that shortcut for 3 cross 3 determinant. And guys, let us say we are having a determinant like this: 1, 2, 3, okay, 2, 4, 5, 1, 3, 6. Let us say this is the determinant we have. And if you want to find out how much duration take, dear, I feel it should take around 2.5 to 3 hours. Okay, so 2.5 to 3 hours would be required, and maybe we will try fastly, like differential equation we have completed in lesser time. If we will go fastly, we can complete it fast also. Okay, soon also. So when we are talking about this, how you can expand it, that you know that I have already shown you. But if you want to apply the shortcut for solving this, what would be the shortcut? So you would be writing first of all 1, 2, 1. This is the first column. Then 2, 4, 3. This is the second column. Then 3, 5, 6. This is the third column. You would be repeating the first column like 1, 2, 1. you would be repeating the second column like 2, 4, 3. Now, my dear, what you would be doing, you know, determinant is having something D. Okay, D for down. So you would be going for this multiplication. 1, 4, 6. Then you would be multiplying this 2, 5, 1. Then you would be multiplying this 3, 2, 3. So you can see what you will be getting. 1 into 4 is 4. 4 into 6 is 24. Then you would be having a plus sign. Then you know these 2 5s are 10. It is 10 into 1 is 10. Then you would be having the third element. 3 into 2, 6. 6 3s are 18. So when you would be writing this, all three elements, now the other three terms would be for subtraction from that. So next three terms would be going like this, like this, like this, like this. So you would be having minus sign. 1 into 4 into 3, it is going to be 12. Then 3 into 5 into 1 is 15. Then 6 into 2 into 2 is 24. So can you tell me what you would be getting as the answer? Can you tell me what you would be getting as the answer? भानु प्रकाश यार शुरू तो होने दो, पहले ही आइगन वैल्यू आइगन वेक्टर पे आ गए आप है. We will try to complete. If you find any difficulty, we may have practice questions on 26th of January. Okay, but we will try to complete each and everything with the questions. I have questions on everything, but if you find any difficulty, we will be having more practice question on 26th January, as I already told you. But we will try to complete the complete chapter. Yes, tell me what would be the answer, guys. Tell me what would be the answer, guys. Wonderful, guys. बहुत बढ़िया, बहुत बढ़िया. Ronaldo, Dhanesh, Shreyas, Saurabh, Utkarsh, yes, Sarath, बहुत बढ़िया. Everybody have given the answer. So this is going to be 24 plus 28. This 24 will be directly cancelled out by this 24. It would be 28 minus 27. The answer will be coming out to be 1. So you should be good. If you are okay with the normal calculation, choice is yours. Okay, I have given you this shortcut, but the choice is yours whether you want to use it or not. Then guys, we are moving further. This is one more question. Will you try by yourself? Will you try by yourself to find out the determinant again? Very good, Giri K. Will you try to find out the determinant by yourself? Please tell me. Try this and tell me the answer for this. Tell me the answer for this. After that, I will tell you an interesting concept of rotation. I will tell you the interesting concept of rotation. Yes, solve this. Solve this. Solve this, solve this, solve this. Okay, Abhishek is saying -2. Rohan is saying -2. And the answer will be coming out to be -2 only. Okay, yes, it will be coming out to be -2. So I am directly writing here 0, 1, 3 and 1, 2, 1. Okay, this will be the way I will moving. This would be first term, this would be second term, this would be third term. What is the first term? It is going to be 0. What is the second term? 3 3s are 9. What is the third term? 2 1s are 2. Okay, this is the first. Second would be 3 2 into 2. 3 2s are 6 2s are 12. Then we are going to have the next term 1 into 3 into 0. Then the third term 1 into 1 into 1. It is going to be 1. Answer will be coming out to be what? -2. Very good, guys. बहुत बढ़िया. I feel this is fine. When I will tell you one concept, one question of the same type we will do, and then we will move ahead. Important topic we will go for 2-3 questions. Like for inverse, we will do 5 questions. For system of equation, we will do 5 questions. Okay, like that. So guys, now I am going to tell you the concept of rotation, and this question will be your homework question. Okay, so one homework with that. Now we are going for the concept of rotation. That is important. When we are talking about concept of rotation, you will see many time questions are coming from that. What is concept of rotation? Sometimes you will see the matrix like this. 1 alpha, alpha 1. So can you see, like in the first row we have 1 here, alpha here. In the second row we have alpha here, 1 here. Can we feel like 1 is moving in this direction, alpha is moving in this direction? And if I ask you to find out the determinant for that, you know, you would be going for determinant like 1 alpha, alpha 1. Determinant is also represented by delta. So you know it would be coming out to be 1 minus alpha ka square. This is nothing but the delta. Similarly, my dear, let us say, अरित्रो यार तुम हमेशा गलती करते हो यार. सब लोग -2 गलत बोल रहे हैं, तुम अकेले हो, फिर भी कॉन्फिडेंस गजब का है. यही कॉन्फिडेंस पेपर में आपको खराब करता है. कॉन्फिडेंस देख रहे हो, मतलब पूरी क्लास, मतलब 80 से ऊपर बच्चे बैठे हुए हैं, सब बोल रहे हैं -2 और तुम बोल रहे हो नहीं सर आंसर 2 आएगा, -2 नहीं आएगा. अरे भाई, दिस इज 0, This is 3 into 3, 9, and 2, 11. This is 11. And if you will go for minus, this is 3 2 ja 2 ja. 3 into 4, 12. And this is going to be then 1. 12 plus 1, 13. How 11 minus 13 will be plus 2? Yes, yes, yes. Okay, moving further. Okay, sir, this is called circulant property. Yes, Abhishek. So, dear, whenever we are going to have a determinant like that, we are having 1, 0, 0, alpha. Okay, then we are going to have 0, 1, alpha, 0. Then we are going to have 0, alpha, 1, 0. Then we are going to have alpha, 0, 0, 1. So guys, you can see this is the 4 cross 4 determinant, and you can see every time 1 is moving this side, alpha is moving this side. For this case, you will be directly writing the answer 1 minus alpha square ka square. And I feel you understood. If likewise I would be having 6 cross 6, I would be having 1 minus alpha square ka cube. Is it clear or not? Please tell me that. Is it clear or not? Please tell me that. Everybody understood this or not? Like this is a 4 cross 4. Similarly, if I would be having 6 cross 6, I would be having 1 minus alpha square ka cube. Please tell me guys, everybody understood this or not? Then we are moving further. Then we are moving to the concept of minor and cofactor. Wonderful, Ashray, bahut badhiya, Ritro, Arvind. Yes, everybody, fine. This is the concept of rotation, or like Abhishek is saying, circulant. Okay, moving further guys. Moving further, when we are talking about the next concept of minor and cofactor. So guys, when we are talking about minor and cofactor, let us say I am having a matrix A, or let us say Y matrix A. When I am writing like this, I would be writing like this. Let us say Y matrix, we are talking about determinant only, let us say directly. So I am going to write it like this. Let us say I am writing it 1, 2, 1, 2, 3, 4, 5, 1, 2. This is a determinant. Okay. So when we are talking about this, if you are just deleting, let us say I am deleting this row, I am deleting this column. Then my dear, if you want to find out, this is the position, this is, you know, first row, first column. So you would be writing the minor of this position M11 is nothing but 3 into 2, 6 minus 1 into 4. So answer would be coming out to be 6 minus 4 is equals to 2. So do you understand what is the concept of minor? And if you are going to write down the cofactor, let us say ij, you just need to do one thing, minus 1 to the power I plus j into minor of that position. Is it clear for everyone? Everybody understood the concept of minor? 5 cross 5, rotation, bilkul, it is going to be 2 cross 2, 4 cross 4, 6 cross 6, like that. Yes, first of all, tell me everybody understood the minor. So for minor, what we are going to do, let us say I want to find out the minor for this position. So I would be making cross on the first row, I would be making cross on the first column and this position. Then rest element I would be finding out like this. 3 into 2, 1 into 4, I will expand it. And then I would be getting the value of minor. And if you want to find out the cofactor, my dear, then you need to do minus 1 to the power I plus j into mij. Is it clear? Please tell me. This is how we can find out the minor and cofactor. Now we are going to see. हाँ भानु प्रकाश, अभी मैंने adjoint बताया नहीं है, adjoint भी बताऊंगा, don't worry. Right now I have not told you adjoint. Adjoint I also will tell you, but first let us see the properties of determinant. Okay, then we will go for the adjoint. Okay, adjoint or inverse सब बताएंगे, don't worry about that. Okay, so moving further guys, So now we are going to have the properties of determinant which will help us to solve it. Okay, like my dear, if you are going to have any two rows or column are going to be same for a matrix, either they are same or they are in proportion, then the determinant of that would be 0. Like if I am going to write delta is equals to like this, let us say it is 1 to 1, it is let us say 1 to 1, it is let us say 3, 5, 7. So you can see here two rows are becoming equal. So for such determinant, answer is going to be 0. Similarly, if the two columns are becoming same, then also the answer will be 0. And why only same? If you are also having in proportion, like here I have 1, 2, 3, here I have 2, 4, 6. And let us say the third is 5, 7, whatever it is. So here you can see this and this row, they are in proportion. So if I take 2 common, they will become same. So here also determinant is going to be 0 for this. Okay, so these first properties, if 2 rows and 2 columns of a matrix are identical, then determinant is 0. If all the elements of any row or column are 0, then also determinant is 0. So if you have all the any row or any column have all the elements 0, then also determinant will be coming out to be 0. Is it clear for everyone? And guys, whenever you are going to interchange the row or a column in the determinant, then it is going to get multiplied by minus sign. Like let us say I am having a determinant like this. Let us say I am having this A, B, C, D, E, F, I, J, K. So if you are going to interchange these rows, okay, then you would be writing here D, E, F. You would be having A, B, C. You would be having I, J, K. So obviously when you are doing this, you need to multiply with a minus sign. Okay, you need to multiply this with a minus sign whenever you are going for any one interchange. Similarly, when you will be going for 2 interchanges, then minus will become plus. Okay, so this is how we will be moving ahead. So if 2 rows or 2 columns of a matrix are interchanged, then the sign of the determinant will change. Similarly, guys, if you are going to interchange 3 rows, means 2 times interchange happen, then minus will get cancelled out. Now, my dear, there is a very important point where matrix and determinant are getting differ from each other. Whenever we are going to have a matrix, let us say ABC, let us say DEF, let us say IJH. Then if you are going to multiply with any constant to this matrix, then that multiplication will be happening to all the terms. Guys, I want to know from you, like one session of differential equation is happened. This is matrix determinant going on. So we are going to complete a chapter in 2.5 hours. Okay, around. So will it be fine for you, because we are going for concept and practice? Or you want only practice? So you can tell in the comment section if you means you are okay with this way, or you want only practice. So I can change in only practice session also from the next session. So I want to go as per your convenience. Is it clear? Like I am going, a good revision is going on with the questions. Okay. Can we find determinant n cross n? Dear, I already told you determinants are always square. My first statement of the determinant was determinant is always a square. Okay. Everybody is happy with the way we are moving. So guys, if you are going to multiply with a constant k in the matrix, then that k will be multiplied to all the terms. Okay, all the terms. So you can say whenever you are going to have a term, let us say ka, kb, kc, you are going to have kd, ke, kf, like that. We are going to have ki, kj, k. So you can say maybe your matrix was like that. So if your matrix is like that, k can be taken common like that. But my dear, whenever we are talking about a row, whenever we are talking about a determinant, then here if you are going to multiply with a constant, that constant will be multiplied with any one row or one column. It is not going to be multiplied with all the rows and all the column. Like you can see here, we were having KA1, KA2, KA3. We have taken K out, okay, and this row became A1, A2, A3, B1, B2, B3, C1, C2, C3. And determinant will become K times delta if delta is this. So the point is, whenever we are going to have a constant multiplication with matrix, it is going to multiply with all the elements. But when we are going to have a multiplication with the determinant, then either a row or a column would be multiplied by that. Is it clear? So guys, here, if you are going to have a determinant of this matrix where k is multiplied to all the elements, if you are finding out determinant of this, you know k would be taken common from first column, second column, third column. So outside you would be getting k cube, which is nothing but the order of matrix, and rest terms you would be getting as same, that is a, b, c. If you are talking about determinant of that, a, b, c, then d, e, f, then I, j, h. So when we are going to have determinant of this matrix, it would be coming out to be k cube, because k will be coming common from here, k from here, k from here. So everybody understood? Now my dear, we would be having something called as transpose. In the transpose, you know, row are converted into column, columns are converted into row. So determinant of a matrix is equals to determinant of its transpose. Okay, so definitely this is also a property. Whenever you need to go for transpose, its determinant is not going to change for sure. Okay, then moving further guys, that property I already told you. Okay, that property I already told you, that also I have told you. Now the seventh property, if you are going to have a matrix written like that this row you can write it as a1 plus lambda 1, a1 plus lambda 2, a3 plus lambda 3, like that, a2 plus lambda 2. Then you can also separate it like a1, a2, a3, b1, b2, b3, c1, c2, c3 plus lambda 1, lambda 2, lambda 3, and rest would be remaining in the same way. This property also we would be using a number of time in solving a question. Is it clear for everyone? So this is one more property we have seen, and now slowly we are moving to the practice questions guys. Now my dear, we are moving to the practice questions. Okay, so next we are moving further. Now my dear, we are talking about inner determinant whenever you are going for the row operation and column operation. While going for row operation, like if you are operating on row 2 and you want to go for addition of row 2 elements plus 5 times row 1 element, you would always be doing this coefficient with others, but you would never be adding coefficient here, because if you are going to do any coefficient here, then the determinant is going to change. That is why we never do this kind of thing. So whenever we are going for any row or column operation, we keep the coefficient of the row on which the operation is to be performed as 1 only. Okay, when we are changing the row, when we are changing the column, minus 1 is multiplied. So next we are moving further. So now we would be doing some questions. Okay, and with the questions we would be understanding. Yes, this is the question. Here you need to tell this equation of what will be coming. This is the first question we are doing. So now we will do 4 or 5 questions on the properties of determinant, then we will move further. So guys, everything I would be covering in a nice manner. Just sitting in this session, you are going to revise it nicely. Okay, a good revision is going on for you. You just need to attend the session, nothing more than that. Okay. And do like the session guys. Do like the session, share the session. Solve it. Okay, majority of you have already answered this question. Majority of you have already answered this question. चलिए guys, बढ़ते हैं आगे. How to do this? So guys, first of all, when you are going to expand this x, okay, I'm not normally going without shortcut. It is 8 minus 0 minus 2. You would be having 4. Then you would be having plus 4. 4 minus 8. So you would be having, it is equals to 0. It is already given. So 8x minus 8 minus 16. Yes, so 8x would be coming out to be 24. X would be 3. So you can see it is representing a straight line. X is equals to 3 is this. Okay, if this is origin. So answer would be A for this. Very good guys. बहुत बढ़िया. Everybody have done this nicely. Very good Ashray. Next question is this guys. So my dear, whenever you are going to get a 4 cross 4 matrix, whenever we are going to have a 4 cross 4 determinant, it is going to be very difficult to expand it. And you may be saying, sir, can we go for the shortcut? Then I will say shortcut was for 3 cross 3. So whenever we get 4 cross 4 determinant, what you need to do? You need to make one thing, that you need to make all these elements, or you can say any one column elements, you can take like that and you will make them 0. If they all will become 0, I just need to go for one matrix multiplication, one determinant calculation. So my dear, if you want to make it 0, what you can do? You can do for the row operation R2. What should be the row operation we should do here? We can go for 1 minus 1 is 0. So you would be going for R2 minus R1. And here we have 2. So we can write R3. And here we would be going for R3 minus 2R1. So I am covering all the types of question. So when you would be doing that, You know, first row is going to be unaffected, 1, -1, 0, 1. Row operation are not changing the determinant. Column operations are not changing the determinant until you are interchanging them. So when we are talking about 1 - 1 will become 0. 2 minus of -1 will become 3. 3 minus of 0 will be 3. 4 minus of 1 will be 3. Okay. Then you are having the next. 2 minus 2 is going to be 0. Then 3 minus of you can say -2. It is going to be 5. Then 4. You are going to have, this is 4. Then 9 minus 2 is going to be 7. And it is 0, 1, 0, 2. Now, you know, if you want to find out the determinant for that, it is simply 1 into this. 3, 3, 3, 5, 4, 7, 1, 0, 2. Now I feel I can expect from you that you can solve this question after that. Yes, everybody. So I feel answer is given by Rohan Mandal as 3. What about others? Rohan Mandal have said the answer to be 3. What about others? Tell me. Yes. So every type I will cover. If you get 4x4 determinant, this is how you would be solving it. Okay. Tell me what is the answer. Rohan have said 3. Faninder have said 3. Now you just need to apply the shortcut for 3 cross 3. Srinath is saying 3. Kuldeep is saying 3. Shreyas 3. Yes, Sogata 3. Ronaldo 3. Kunal 3. Giri K 3. Very good. Very good, Utkarsh. Very good, Ginu Singh. Very good, Akang. Yes, Akshara. Very good, Saurabh. Very good, Aritro. Bahut badhiya. So guys, now we are moving further to the next question. I feel everybody can do that. So, can I avoid calculating determinant now? Can I have faith on you ki hum kar lenge, sir? Very good, Vinay. So the answer for this will be coming out to be 3 for sure. Okay, 3 for sure will be coming. Moving further, guys, to the next question. Next question is this, and I am expecting you would be using the properties of determinant and calculate the solution. Otherwise, don't worry, I will help you for sure. But first, I have expectation from you. Try to solve it and get the answer. Try to solve it and get the answer, guys. Very good. Rohan is saying 0. Kunal is saying 0. Sushmita 0. Srinath 0. Okay, Kuldeep is saying 0. Sarath, Shreyas, Akshara, Abhi, Sake, Harish. Very good. Very good. Everybody is saying 0. Wonderful. So I feel everybody understand this property first of all. We would be writing it in this way. ABC, then ABC, then XYZ. Plus. We can write it as once again ABC. And this can be broken like 2x, 2y, 2z. Then we have x, y, z. You can see here these two rows are same. So answer will be 0. Here these are in proportion. Answer will be 0. 0 plus 0 is 0. Wonderful, guys. The answer for this is going to be 0. Very good, guys. Moving further. This question, guys. Moving further this question. This time you need to solve it. Just try to solve it. You can make row operation to make the calculation easier here also. Okay. Like you can go for R2 minus R1 and R3 minus R1. After that you can expand in one term, you will get the answer. Okay, you can go for R2 minus R1, R3 minus R1. Then in one calculation, you will get the answer. Row operations are going to make your task easier. Okay, so try to solve it, guys. Try to solve it. Very good, very good. Rohan is saying minus AB, all others are saying plus AB. So I feel Rohan would definitely understood his mistake. So when we are going for R2 minus R1, first row is going to be unchanged. 1 minus 1 is 0. This is becoming A. This is becoming 0. This is going to be 0. This is going to be 0. This is going to be B. Answer will be coming out to be AB. So when you see this question, answer is coming out to be AB. Then my dear, whenever some students see this question, they are making the mistake in the other question. Okay. So that's why I have to do the one more question of this type. And that one more question of this type is looking like this. Just by previous question, can you tell me what should be the answer for this? Very good Dhanesh, very good Bhanu Prakash, very good Saurabh. Next question is this. If anybody found, sir, please wait for that question. I will wait. Okay, so I am expecting everybody would be doing. Ronaldo is saying ABC. Answer is wrong. Answer is not ABC. Answer is not ABC. That's why I said generally students are doing mistake here. Here, if you are having all ones, then only it is possible. Because of this 1 minus a, this time when you will go for row operation, you will not be getting this to be 0. So that is why here only one operation can be done. That is R2 minus R3. Nothing else can be done. Okay, only this operation can be done here to make this as 0. Okay, so this time ABC is not the answer, and that's why I have kept this question just after this, so that in the exam you don't do this mistake. Okay, so I am taking care of each and everything. Maybe we are at the end of the preparation, but I will be taking care of each and every minute thing where you guys can make the mistake. So just you need to attend the session, nothing more than that. Just by attending, many of your negative marks would be rectified. So just solve it, guys. Just solve it. Just solve it now. So now when you will be solving it, you need to go by the normal expansion method. This is 1 plus a, 1, 1. And when you would be going for, there is no change in this 1, 1 plus b. It is 1. 1 minus 1 is 0. It would be minus b and it would be c. Now you can very easily expand it and tell me the answer. After expansion, I feel you would be getting the answer. Solve it. This time, I feel you would be getting the answer something like that. AB plus BC plus AC plus ABC. Please do check whether am I correct or not. I have written just like that. Okay, I have not solved this question. Okay, yes, previously someday I have solved, but not today. Very good, Bhanu Prakash. Answer is matching. Wonderful, Bhanu Prakash. Yes, Akshara, you got your mistake or not? Please tell me. Then we are moving to one more question. One nahi, 2, 3 more questions. After 2 to 3 more questions, we will go for the second part. First part will be over. So we are having total 4 parts today, and in 55 minutes, first part is going to be there. Very good, Jimmy. So answer is AB plus BC plus AC plus ABC. So why I have done, just to tell you ki if we have all ones, then only we can get the answer as like BC and all. If all ones are not there, you cannot write like that. Very good Dhanesh, very good Saurabh, very good Abhinav. बहुत ही बढ़िया guys. बहुत ही बढ़िया. So guys, now moving further, this is your homework question now. Okay, this is your homework question. I told you one homework in between you will get. Now my dear, the next, okay, I would like to tell you from 27th of January, the last chance to appear for Mega Mock Challenge and to see where you lie in all among India student. This will be live from 27th January to 3rd of February. Okay, so you can appear for this, and next we are moving further. You can download the app so that on 26th of January, you can join our session. This is 3 cross 3 determinant is given and you need to solve it. You can see 1 by A, 1 by B, 1 by C, ABC, BC, CA and AB. I feel it is very easy to solve. Solve it and give the answer for this. Solve it and give the answer for this. This is very easy. Dear, why to no Prithvi, that can be done if all the elements, like if you are asking about the previous one, if in one row they are 1 plus A, 1 plus B, 1 plus C, then we can do like that. Okay, like if you are having 1 plus A, 1 plus B, 1 plus C, then you can go for separation. They were in different rows, then you cannot do. Okay, Rohan have given the answer. Prithvi, did you get it? Prithvi, did you get it? If it would be 1 plus A, 1 plus B, 1 plus C in same row, then we can separate them. Fine. Everybody answer is you just need to multiply and divide it by ABC. So when you would be going for multiplication and dividing by ABC, so I would be having outside ABC ka division, inside multiply ABC with this column. Okay, when you will be multiplying, if you are saying ABC multiplied, ABC divide, then I can multiply this ABC with the first column. Here you would be getting BC, here you would be getting AC, here you would be getting AB, and which is same as BC, AC, AB. Okay, so two columns are becoming identical, so answer will be 0 for this. Answer will be 0 for this. Answer will be 0 for this. Now, my dear, the next type is very, very important. Next type is very, very important, and that have been observed in many of the paper. Okay, wonderful guys, wonderful guys, wonderful guys. So this type of question, whenever you see, there is a wonderful identification I would be giving you. What is that? You can see the summation of all the elements of every row is same. You can see this. Summation of all the elements of every row is going to be same here. Okay. Is it clear for everyone? Is it clear? X plus A plus A plus A. It is X plus 3A. So what you would be doing here, you would be saying C1 is operated. C1 plus C2 plus C3 plus C4. When you would be doing this, you know it would become X plus 3A. Here also X plus 3A. Here also X plus 3A. Here also X plus 3A. Then my dear, you know, here we will be left with AX, AA. Then we would be having AX, A. Then you would be having AX. Okay. Now once we have this, now you can operate. First of all, take X plus 3A common. So when you would be considering X plus 3A outside, you would be having this 1, 1, 1, 1. This is the thing which you are looking for whenever we get 4 cross 4 determinant, so that you can make these 3 rows as having 1, 1, 1 will become 0, 0, 0. So here we have the same AAA. Here we have the same XAA. Here we have the same AXA. Here we have the same AAX. Now what you need to do, only one thing, the row operation. You would be going for R2 minus R1. You would be going for R3 minus R1. You would be going for R4 minus R1. Because going for this, all these 3 will become 0. And when these 3 will become 0, you need to go for only one calculation of determinant. Rest I feel everybody can do. And Kuldeep have given the answer as X plus 3A into X minus A ka cube. The same answer is given by Kuldeep and Rohan as well. So when you will be going for this, what you would be getting, I am telling you, X plus 3A would be outside. Here you know we are having 1A. So you can separate 1 minus 1 0. This is X minus A. This will become 0 0. Then 0 0 X minus A 0. 0 0 0 X minus A. So just answer will be X plus 3A into X minus A ka cube. This would be the answer. Very good, Faninder. So guys, everybody understood or not? Are we ready for one question? Can I expect by yourself? One question same you will be doing. Please tell me. One more question of this type will you be doing? Very good guys. Very good guys. So I am going, okay, last class homework only, I don't know anybody have done or not, but one student asked me on Telegram. So today I will be sharing you the solution of the first session. Okay, moving further guys. This is your homework. This is your question which you will be doing right now here. The same question I won't answer from you guys here only. You can see this is 1 plus y, 2, 3, 4. Summation of all the elements is once again same. Okay, so you do this question here only, and then I will be giving you one homework and we will move to the second topic. First topic is over from here. Okay. Great, Faninder. Great, Faninder. Very good. So can you tell me the answer after solving this? Okay, great, Faninder. I will share the solution today if you want. वंडरफुल गाइस, बहुत बढ़िया. वंडरफुल गाइस, बहुत बढ़िया. Tell me guys. नहीं भाई, जीरो तो नहीं आएगा, जीरो तो नहीं आएगा. Here once again you will say C1 is operated C1 plus C2 plus C3 plus C4. When you would be going for that, 4 plus 3, 7 plus 2, 9. It would be 10 plus y. 10 plus y. 10 plus y. 10 plus y. Is it clear? So here you would be having 10 plus y. Next element would be 2, 3, 4. 2 plus y, 2, 2. 3, 3 plus y, 3. 4, 4, 4 plus y. Next, you know, you need to take 10 plus y common. Then you need to go for R2 minus R1, R3 minus R1, R4 minus R1. And I feel many of the students have already given the answer for this. And the answer will be coming out to be 10 plus y into y cube. 10 plus y into y cube is the right answer. Is it clear? Very good guys. Very good guys. Very good guys. बहुत बढ़िया. Everybody have done it. Wonderful. Wonderful. बहुत ही शानदार guys. So this is the completion of the first part from here. Okay. Then guys, this is a homework question to you. Okay. And whatever the homework question, you will get the solution of theirs also. Okay. Homework question solution also you will get. Yes, guys, if you have not subscribed the channel yet, do that so that the other sessions notification you get. Now, my dear, like we have completed the determinant, we are going to enter into the matrices. So you can see Abhinav sir is there to motivate you guys. He's always joining live whenever he finds that, yes, the students want some motivation. You know that in the night also, sir, have taken a session. Morning, sir is there with you. So the whole day is dedicated to you guys. Yes. So guys, when we are talking about the types of matrices, likewise, we have seen the types of determinant. We are having the types of matrices here. When we are talking about row matrix, my dear, if you are going to have a single row and multiple column, let us say this matrix 1 to 1. You know, this is not a square matrix, because I said that matrix can be a square, can be a rectangle, but determinant is always square. So you can see this row matrix 1 to 1, because one row is there, column may be any number. Similarly, column matrix will be like this 1 to 1. Elements can be anything. Null matrix is a matrix for which all the elements are 0. Like if we are having a matrix like this 0, 0, 0, 0. It is also represented like this. So if all the elements are 0, we call it as null matrix. Then diagonal matrix is similar to the diagonal determinant we have seen. In the diagonal matrix, you would be having the principal elements, principal diagonal elements, A, B, C. Okay, A, B, C, all should not be 0. At least one of these three should be non-zero. Then we would be calling it as diagonal matrix. Upper triangular, you already know, we have discussed previously. We are having A, B, C. Then we are going to have D, E, F. So these other elements must be 0, and out of A, B, C, D, E, F, at least one should be non-zero. Okay. Is it? Ha. Yes. Ha, Vinod sir, I have seen that. So guys, do subscribe the channel if you have not done yet, so that other sessions notification also you will get on time. हाँ शुभम, सब कुछ होगा भाई, सब कुछ होगा. ओके, सब कुछ होगा. एंड यस, थोड़ा सा उसमें बस इतना सा कैच है कि फॉर दैट वी नीड टू हैव वन एक्स्ट्रा सेशन ऑन द डे विद एप्टीट्यूड. ओके, आई फील देयर इज नो प्रॉब्लम विद दैट टू यू. You guys would be happily coming. So we are covering everything. You just be there with us. Nothing else is required. Okay, guys. So upper triangle, lower triangle, we have seen all the things. Now we would be going for the other types of matrices. Okay, row matrix we have seen, column we have seen, null matrix we have seen, diagonal we have seen, upper triangular we have seen, lower triangular. Whenever we are talking about, I feel everybody can understand that it is A, B, C, D, E, F and 0, 0, 0. So whenever we have, this is said to be lower triangular matrix if the condition applied, all these elements are not 0. If all these elements are not 0. Is it clear? Okay, okay. Okay, sorry sir, actually मैं थोड़ा सा नींद में हूँ, मुझे लग रहा है. So guys, scribble pad, many students were asking for the scribble pad. Okay, कि how to use the scribble pad in the GATE examination, because that is very important thing, because right now here you have the rough notebook and you are doing anything, but there you would be having a scribble pad, how to utilize that efficiently. For that, me and Abhinav sir are going to give you a session on that. Okay, yes. Sorry sir for that. Okay, moving further. Now we are having the submatrix. Sir, थोड़ा मैथ पढ़ाते मुझे लग रहा है कि फर्क आ गया है. Okay, yes. Okay, so we are actually, yesterday I had a journey to come to the office, that's why you may be feeling that. Okay, so let's move the submatrix. So guys, whenever we are going to have this as A11, A12, A13, A21, A22, A23, let us say A31, A32, A33. So when we are talking about the submatrix, my dear, when we are talking about submatrix, so guys, if you are going to delete any row or any column, let us say I am deleting first row, I am deleting second column, any row or any column, and let us say I am deleting this first row and second column, I am left with some element A21, A23, then we are going to have A31, A33. So this type of thing is said to be the submatrix. Okay, it is the part of the matrix actually. Okay, is it clear or not? Please tell me. So like you can also have one more cancellation, then you would be left with A31 and A33. This is also the submatrix. So submatrix can also have even one element. Like also if I do this, then I would be having the matrix like A31. So submatrix is defined like that. Everybody, please tell me, everybody understood about the submatrix or not? So it is nothing but the part of the matrix. Is it clear for everyone? This is the submatrix. Then we have equal matrix. So if you are writing that matrix A is equals to matrix B, then my dear, this is only possible if every element of A is equals to every element of B. Otherwise, it is not possible. So equal matrix means if every element of A will be equals to every element of B, then two matrices are going to be equal. Then guys, we are having the identity matrix. So guys, this is important. Till now, whatever we have seen, maybe every matrix would not be very important and coming again and again, but identity matrix would be coming again and again. First of all, identity matrix is a square matrix. Second thing is diagonal matrix with diagonal elements as 1. So identity matrix is shown like this. If we are going to have 1, 0, 0, 0, 1, 0, 0, 0, 1. So this is said to be the identity matrix. Is it clear for everyone? This is said to be the identity matrix of order 3 cross 3. Okay, of order 3 cross 3. And whenever we are talking about the 2 cross 2 matrix, it is going to be 1, 0, 0, 1. Okay, this is also identity matrix of order 2. And my dear, in the same matrix, whenever we are talking about, if this element is not 1, but any constant k, maybe this element can be 2, 2, 2, 0, 0, 2. Then that matrix is said to be a scalar matrix. So everybody understand the difference between scalar matrix and identity matrix, because here students are getting confusion that what is scalar matrix, what is identity matrix. So if that 1 is replaced by a constant, it becomes a scalar matrix. So scalar matrix also have the same characteristic. It would be a square, and diagonal matrix with diagonal would be that element, and all other element would be 0. So only principal diagonal element r equals to 1 is identity matrix. Only principal diagonal elements are some constant is equals to scalar matrix, and all other elements would be 0. That is identification of identity matrix. Okay, the symbol for that may be in or in cross n, because it is always a square matrix. I can show it like in also. There are some other properties of identity matrix, that its determinant is 1. When we are going to multiply identity matrix any number of time, you will get once again the identity matrix. If you are going to take the inverse of identity matrix, it will come out to be identity matrix. If you are going to multiply any matrix with identity matrix, once again you will get the same matrix again. Okay, this is the case. And guys, now we are going to have scalar matrix, I already told you. Then my dear, we are going to have the addition of two matrix. You know, whenever we are going for addition, order for both the matrix should be same. You can do the addition on rectangular matrix also. You can do the addition on square matrix also. The only thing is their order should be same, because elements are directly added. Like if I have a matrix like this, A, B, C, D. The next is E, F, G, H. E, F, G, H. Then you can say it is A plus E, B plus F, C plus G, and D plus H. This is how we can find out the addition of a matrix. Very easily we can find out the addition of the matrix. Okay. So guys, now there are some properties of addition. Like if you want to subtract matrix B from A, you just need to multiply the minus of matrix B with the A. If you are talking about the property of commutative, yes, addition is commutative. If you add A into B or B into A, they will remain the same. Associated, if you are going to have A plus B plus C, or you are going to say B plus C, then add plus A, it is going to be same. Then if you are going to say, if A plus B and A plus C are equal, it means B is equals to C. Okay, otherwise it is not possible. Then if A plus 0 matrix, null matrix will be A. C is equals to A plus B. Okay. So guys, whenever we are talking about this, if you are going to have the multiplication of matrix and addition of matrix, there is a difference. If here, when we are talking about this C, whatever be the order of A, the same would be the order of B. Then only they can be added. Okay. Whenever we are talking about production, or you can say multiplication of the matrices, it is having some differences. What is the difference of multiplication? So before that, I would like to say, if C is A plus B, then the determinant of C would be equals to determinant of A plus B. Okay, but not equals to determinant of A plus determinant of B. Remember that this is a very important thing. Okay, 6 properties important here. Now, my dear, we are moving with the multiplication of matrices. For multiplication, the very first condition is the number of column of the first matrix should be equal to number of row of the second matrix, and the order of the resultant matrix will be M cross P. You can see that, M cross P. And my dear, this is the condition. If this is not satisfied, we cannot multiply two matrices. If you want to multiply two matrices, it is condition that the number of column of first should be equal to number of row of second. And guys, whenever we are talking about A plus B, it is coming out to be M cross P. Here, when we are talking about the square matrix, okay, sorry, this is for addition only. Leave it. This is for addition only. Okay, is it clear for everyone? Now we are moving further. Like I told you, when we are writing the expansion of a determinant, you know the total number of terms are coming out to be n factorial. So sometimes they are also asking the total number of multiplication of elements required in a multiplication of two matrix. Then it is M cross N cross P. Okay, I will be showing you this with the example, don't worry. And similarly, the total number of addition of the elements required in the multiplication of two matrices, M into N minus 1 into P. I am going to show you them with the example now. Let us say we are having these two matrices. First of all, you can say this is 2 cross 3, this is 3 cross 2. So you tell me, multiplication of AB is possible or not? Multiplication of AB is possible or not? Please tell me. Multiplication of AB is possible or not? Please tell me. Multiplication of AB is possible or not? Please tell me. Yes, it is possible, because the number of column of first matrix is equal to number of rows of the second matrix. So guys, now if we are going to multiply matrix A with B, then you would be doing it like this. You will be considering the row of this and column of this. So 1 into 1 plus 2 into 1 minus 3 into minus 1. So you would be having 1 into 1 plus 2 into 1, then 3 into minus 1. So the answer would be coming out to be what? It is coming out to be 0. You will write this element as 0. Then you know you would be having second row, second column. Is it clear? Because you can see here we are going to have first row, second column. Here it is 2, here it is 3, here it is 3, here it is 2. So this matrix would be coming out to be 2 cross 2. So we have multiplied first row with first column. Now we will multiply first row with second column. So 1 into 2 is 2. 2 into 1 is 2. 3 into 0 is 0. So what you would be getting, are we getting 4 here? I feel everybody understood. Now the second row will be multiplied with the first column. So you would be having 1 into 1 plus 1 into 1 minus 2 into 1. We are getting 0 once again. And when you will be multiplying this with the second, you would be having 2 plus 1. It is going to be 3. Please tell me guys, is it clear or not? Then we are moving further. Please tell me guys, is it clear or not? Then we are moving further. Please tell me guys, is it clear or not? Then we are moving further. So when we are talking about how many multiplications are being done, then the number of multiplication terms are going to be equals to nothing but they are equals to m cross n cross p, and the number of additions we have done is m into n minus 1 into p. So always remember this. Okay, they can ask you the direct question from that. Okay guys, now we are going to have some other properties. Then we have some wonderful questions for you. A into B is possible, then it may not be possible that B into A is also there. If you are having A into B, maybe B into A is not there. Okay, then we are talking about not commutative. A into B is not equals to B into A. Similarly, when we are talking about associated, yes, it follows. If we are going to multiply B and C and then multiply with A, it will give you the same result when you multiply A and B and then multiply by C. Distributive, yes, it follows. Then my dear, if you are going to have a matrix A like this, then A square can be written as A into A if it is a square matrix. Okay, otherwise it cannot be. Because if it is a square matrix, we can directly write it. Why? Because you know, if it is 2 cross 2, it would always be able to multiply a 2 cross 2 with 2 cross 2 matrix. Okay, so you can write A square as A into A cube as A into A if it is going to be a square matrix. Okay, then guys, moving further. When you will multiply a matrix with the null matrix, it will be getting into null matrix. Multiply by identity matrix will become the same matrix. If A into B is coming out to be 0, it is very, very interesting. It is very, very interesting. If you are going to have the product of two matrices, A into B, it is coming out to be 0. Then it can be possible in 3 cases. If A matrix is a 0 matrix, B matrix is a non-zero matrix. Yes, it is possible. Second case can be the A matrix is a non-zero matrix, B matrix is a 0 matrix. Yes, it is possible. Third case can be if both of A and B are 0. Then also it is possible. But whenever we are going to have A as non-zero, B as non-zero, then also it is possible if both A and B are non-singular matrix. Non-singular or singular, what do you say? Non-singular or singular, what do you say? It is going to be singular. What do you mean by singular? If the determinant of A is equals to 0, if the determinant of B is equals to 0. If this condition satisfies, then even though both the matrices are not 0, you would be getting their product to be 0. From here, questions have been asked in the previous years. That's why it is important. Please tell me, everybody understood or not? Because after that, we are going to the concept of inverse. I will give you the shortcut to find out the inverse. Is it clear for everyone? Yes, it is going to be singular. Okay, singular means whose determinant is 0. Everybody understood? Are you ready for one more question, guys? Yes, Saurabh. Everybody, yes. Bahut badhiya. Let us see, guys, the wonderful question in front of you. This is the question. And here A is a matrix. Sorry. This is the question. A is a matrix M cross M plus 5. B is a matrix N cross 11 minus N. Both A and A into B, B into A are existing. Find out the value of M and N. Let us see how many of you are giving the right answer. This time I am expecting the answer from you guys. And now after this we are entering into the concept of inverse. After inverse we will see the rank of matrix, then we will see the system of equation. After that we will be entering into the eigenvalues and eigenvectors. Tell me guys, tell me everybody, what would be the answer? You know that if A, B is possible, what is the condition? The number of column of A and number of rows of B should be equal. First condition. Arithro is saying 6. What about others? What about others? I want the value of M and N from your side. 6 is the wrong answer. Rohan have given the right answer. Rohan have given the right answer. Rohan have given the right answer. So if we are going to say this, M plus 5 is equals to N. Okay. This is the first condition. M plus 5 is equals to N. The second condition is if B into A is possible, then this would be the number of column, this would be the number of row. So you would be having 11 minus N is equals to M. 11 minus N is equals to M. So this is equation 1. This is equation 2. You need to solve these two equations and you would be getting M as equals to what? 3. M is coming out to be 3, N is coming out to be 8. Very good guys. Very good guys. बहुत ही बढ़िया. Wonderful. बहुत ही बढ़िया. Answer would be 3 and 8. 3 and 8. Wonderful guys. So guys, now we are entering into the wonderful concept of inverse. Okay. This is the important concept. Everybody knows that sometimes questions are directly coming to find the inverse. So first I will tell you the normal way. Then I will tell you the shortcut. Then we will see 3 questions. 3 to 5 questions. And then we will enter into the rank of a matrix. So let us see the inverse. Very good Arithro, very good Vinay, very good Chandrasekhar, very good Prince, very good Adarsh, Kuldeep, Ginu, Faninder, Saugata, Abhinav, Vamshi Krishna, Akshara. So when we are talking about invertible matrix is a matrix for which inverse is possible. So inverse is not possible for a singular matrix. So inverse is possible when we are talking about singular matrix is a matrix for which determinant is 0. So inverse is possible if determinant is not 0. So first condition is matrix should be a non-singular matrix. If matrix is singular, inverse will not exist. Second thing is A into A inverse is equals to identity matrix. A inverse is inverse of a matrix. We can also write the inverse like this. We can also write the inverse like this. Both are the correct representations. Okay. Then my dear, as you already know, A into B when we are writing I is identity matrix. So if we want to find out in that case, what we will be doing? We will be going for pre-multiplication. Multiplication with A inverse. Okay, here and here. When you will be doing this, B would be coming out to be A inverse. So if you have A into B as identity matrix, B will be nothing but the A inverse. With the post multiplication, you can see A is equals to B inverse. Sometimes questions are coming like that. If we have product of A into B ka inverse, it would be coming out to be B inverse, A inverse. Similarly, if we are going to have A, B and C, let us say these 3 matrices are there. Ka inverse, it would be C ka inverse, B ka inverse and then A ka inverse. Likewise, they are following. So first method to calculate the inverse is the conventional method. In conventional method, what we need to do, we would be given a matrix like that. First of all, we need to find out the minor matrix. After minor, we would be going for the cofactor matrix. After cofactor, if you would be taking the transpose of this, then it would be said to be the adjoint of A. And if you will divide it by the determinant of A, it is said to be inverse of A. So guys, do you want me to solve it by this first a question, or shall we directly go to the shortcut? What is your expectation? Okay, let us go for one question. Okay, that would be better. We are going to have this question and we want to find out the inverse. Okay, first of all, whenever we have a 2 cross 2 matrix, a 2 cross 2 matrix. Let us say this: A, B, C, D. Everybody know you would be having the determinant of A as equals to AD minus BC. AD minus BC. Then you want to find out the adjoint of A. What is the procedure to find out the adjoint of A? First of all, you would be going for minor matrix. What is minor matrix? When you will be going for this, minor is coming out to be D. Okay, when you would be going for this, minor would be coming out to be C. When you would be going for this, minor would be coming out to be B. When you would be going for this, minor would be coming out to be A. Everybody understood the minor? Now you know if we want cofactor. What is cofactor? Cofactor for ij is written as I plus j. This is going to be the power of -1 and into mij. So it means cofactor matrix whenever we are writing. So here it is the first term. First term means -1 की power 1 1. First row, first column, A11. So 1 plus 1 into D. Then we are going to have -1 to the power, -1 to the power. This is first row and second column, 1 plus 2 into C. Then we are going to have the third term, that is going to be -1 to the power 2 plus 1. And then we are having the B. Then we are having -1 to the power 2 plus 2. It would be coming out to be into A. Okay. So while solving this, I feel you will be getting it. It is coming out to be -1 की power 2 is +1. It is D. Then here minus C. Then here minus B and here A. So guys, this matrix is the cofactor matrix. This matrix is the cofactor matrix. Yes, very good, very good. This is the cofactor matrix. If this is the cofactor matrix, you will be taking the transpose of that. So transpose of that will be giving you, what? It would be giving you D minus C minus B A. And what is inverse of A? This. So I would be directly giving you a shortcut for 2 by 2 matrix. Like if you are having a matrix like this, A, B, C, D. Like you have a matrix like this, A, B, C, D. I am giving you the shortcut. What is the shortcut? First of all, take the determinant, which is nothing but AD minus BC. And the matrix would be, you just interchange. This will be D, this will be A. And multiply with the minus term to the others. This is going to be the answer. Very simply, you can take this as a shortcut. So first of all, you need to find out the determinant of A. It is 3 plus 3 minus of 3. Will the inverse be existing or not? Okay. Sorry. 3 minus 2. Sorry. It is coming out to be 1. So what would be the A inverse then? It would be 1 by this into what? 3 would be going there, 1 would be coming here, minus 2 will become, minus 1 will become plus 1, minus 2 will become plus 2. So the answer will be coming out to be the matrix as 3, 2, 1, 1. Is it clear for everyone? Please tell me that. Is it clear for everyone? Yes, Rohan, I can understand. Is it clear or not? Please tell me that. मैं रट के नहीं आया हूं, ठीक है? तो थोड़ी बहुत गलती हो सकती है. Is it clear for everyone? Everybody, please tell me. Everybody, please tell me. Are we ready for the next question? Are we ready for the next question? Okay. So next question is going to be like that. So shortcut for 2 cross 2 I have already given you. Tell me the answer for this. 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 Yes. Not exist. Very good, Kuldeep. Very good, Kuldeep. Here inverse will not exist. You can see the determinant of A is coming out to be 6 to the 12. Minus 12 is 0. So you will directly say A inverse does not exist. Why I have given you this? So that you have a habit of this. First checking whether the inverse is existing or not. For here, can you find out? For here, can you find out? Then we are coming to 3 cross 3 also. Don't worry about that. Solve it. After that, 3 cross 3 questions we have. 1 to 2 questions we will see, then we will enter into the rank. Yes, here the determinant would be coming out to be what? It would be coming out to be 4 minus 6. It is minus 2. Then we are going to have the inverse of A as 1 by minus 2. You know what to do. 4, 1, minus 3, minus 2. Simple. Okay. So like we have done 2 cross 2, there is a shortcut for 3 cross 3 as well. Very good, guys. Very good. Very good. Everybody. Rohan, Faninder, Saurabh, Vamshi Krishna. Wonderful, guys. You guys are doing very nicely. So guys, now let us see about the 3 cross 3 matrix. Okay. So 3 cross 3 matrix is there in front of us. Okay. And we want to find out the inverse for that. I will be telling you the shortcut also. Okay. First of all, what you need to do? You need to write like 1, 2, 2, 2, 2, 2, 2, 2, 1. If I am not wrong, let me give some space to myself because it would be required here. It is 2, 2, 2, 2, 2, 1. If you want to find out the determinant, you need to repeat 2 columns. 1, 2, 2, then 2, 2, 2. First of all, we will be finding out the determinant of A from here. And how you find out? I have already given you the shortcut for that. You were going for this. 1 into 2 into 1. You were going like this. So 1 into 2 into, this is 2 into 2 into 2. This is 2 into 2 into 2. So you would be saying this is 2, 2, 8, 8. It is coming out to be 18. Then minus. 2 into 2 into 2 is 8. 2 into 2 into 1 is 4 and 4. What you are getting? Are we getting 2? Yes, it is coming. Now, my dear, if you want to find out the inverse, you need to do one thing. Just write down the first 2 rows as it is. Like here 1, 2, 2, 1, 2. Then 2, 2, 2, 2, 2. Now, my dear, what you need to take is, you just cancel the first row, cancel the first column. Now, you need to write the A inverse directly. It would be 1 by A determinant into. Now, you would be making the 2 cross 2 determinant here. You would be getting 2 minus 4. Is it clear? Will you be getting 2 minus 4? So you would be writing it minus 2 here. You will go in the next element like this. Here you are going row wise, here you will go column wise. So it is going to be 2 into 2 minus 2 into 1. It would be coming out to be 2. Then you would be doing this. 2 into 2 minus 2 into 2 will be 0. This is the 1 row and 1 column case. Then we will be going for the second row. Second row is this. 2 to the 4 minus 2. It is 2. Then you would be going for this. 1 minus 4. It is minus 3. Then you would be going like this. 2 to the 4 minus 2. It is 2. Likewise, you would be repeating this for the one more time. 2 to the 4. It is 0. 2 to the 4 minus 2. Then you would be having 2 minus 4. Please tell me, guys, everybody understood this or not? Everybody understood this or not? Please tell me, everybody understood this or not? Everybody understood this or not? Everybody, Saurabh, Dhanesh, this is the shortcut we will be applying to find out the inverse. No need to go for minor, cofactor. These are time-taking things. So you can directly do. Even whenever we are going to do this once only, determinant also will be coming from the same thing. Inverse also will be coming from the same thing. Everybody. Yes. Wonderful, guys. So will you try to do 1 to 2 question from your side? Will you try to do 1 to 2 question from your side from inverse? Yes, like this is the question. Find out inverse. Only 2 questions we will do. Rest I will give you homework because we just need to revise the things. Yes, very good, very good. This time you would be doing. This time you would be doing. This time you would be doing. Okay. So do this. Then we will be going for the symmetric and skew symmetric matrix. Solve it, solve it, solve it. After that we have symmetric and skew symmetric, then orthogonal matrix. After that we have rank of a matrix. And after rank we have system of equations. Okay. So I feel before 1 p.m. we will complete the session. Solve it, solve it, solve it. Everything will be done in these sessions. You guys are going to enjoy like you are master in the subject. Confidence booster, these sessions would be 1, 2, -2, -1, 3, 0, 0, -2, 1, 1, -1, 0, 2, 3, -2, 1, 2, -2, 1, 2, -1, 3, 0, -1, 3. Okay. First, you will be finding out determinant. So I am expecting that determinant you guys will be calculating by yourself. And rest I would be doing. Okay. So I will be cancelling first row, cancelling first column. Bhargav, this is the question you have to do here. After that, you will have homework. First, tell me the determinant what you are getting. Tell me the determinant what you are getting. Very good. 1 is correct. 1 is correct. 1 is correct. So now I would be writing the inverse. 1. For inverse, you know, first this 3 minus 0. Then this 0 minus of -1. Sorry, here. Then we will be going like this. 0 plus 2. Then this 4 minus 2. 1. -6. 2. 5. Wonderful, guys. Many of you have already done it, and that is also correctly. Is it clear? So guys, now can we go for the next part? Can we go for the next part? Very good. Everybody, I feel understood this. Good morning. Good morning, bhai. Rohi, good morning. This would be coming +6. You're correct. Wonderful, guys. So now we are entering into the symmetric and skew symmetric matrix. So my dear, whenever we are talking about symmetric and skew symmetric matrix, first of all, they are going to be always the square matrix. When we are talking about symmetric matrix, matrix A and its transpose will be equal. And when we are talking about skew symmetric matrix, then A would be coming out to be minus of A transpose. Okay, this is for skew symmetric. And my dear, whenever we are talking about as A and A transpose are equal, so for symmetric matrix, when you will subtract A transpose from A, you would be getting null matrix. But here, A matrix plus A transpose matrix would be coming out to be 0. This is for skew symmetric. So I have written both the results in front of you. Left hand side would be symmetric, right hand side would be skew symmetric. Next, my dear, I would like to tell you, like if you have this, you can see this matrix. If you would be taking the transpose of that, you would be having 1, 2, 2, 1. So this is a symmetric matrix. This is a symmetric matrix. This is also a symmetric matrix. Identity matrix is also a symmetric matrix. Okay, these all are the examples of symmetric matrix. Now, my dear, if you see the skew symmetric matrix conditions, I already have told you. One more condition is principal diagonal elements of skew symmetric matrix is always 0. Otherwise, it is not possible. Okay, and next thing is sum of all the elements in the skew symmetric matrix will also be 0. Like I would give you the example of that. Like you have this matrix. You can see this is 0, 0. The sum 2 and minus 2 would be 0. Okay. I would also like to tell you one more thing, like this matrix. You can see if this is 3, this is minus 3. This is 4, this is minus 4. This is 6, this is minus 6. This is the identification of this type of matrix. So all these elements would be 0. You can also write like this. If I am saying skew symmetric matrix, all these 3 are 0. Here if I am writing 2, 4 and 5, it is understood. Here it would be minus 2, here it would be minus 4, it would be minus 5. This is how the matrix would be coming. You can see the summation will be 0 and all. And guys, now we are going to have, if we are having this any 2 by 2 matrix, then I would like to tell you that if any matrix A is there, we can write it as a summation of symmetric and skew symmetric matrix. Okay, so this is how we can write two matrices. Is it clear for everyone? Rohan, it is valid. It is valid, yes, it is valid. If elements same, yes. Is it clear, guys? Is it clear for everyone? Please tell me that. Yes. So if we are talking about skew symmetric matrix, yes, when we are talking about determinant of A, are you asking about the determinant of A? So yes, it would be 0, not always. Either it would be 0 or it would be a perfect square. Either it would be a 0 or it would be a perfect square. Can you tell me when it will be 0, when it will be perfect square? Yes, please tell me. Yes, Rohan, this is going to be 0 if the n is odd, like 3 cross 3. It is going to be a perfect square if it is 2 cross 2. Like let us say we have 0, 0, 2 minus 2. What would be the answer? It would be 2 ka square. Is it clear? Is it clear for everyone? Everybody understood or not? Please tell me. 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 Tell me, guys. Everybody. Yes. So moving further, guys. Now we are going for the orthogonal matrix. So when we are talking about the orthogonal matrix, my dear, whenever we are talking about the orthogonal matrix, it is also a square matrix. And the condition here is transpose of A will be inverse of A. Transpose of A will be inverse of A. Let us say we are having a matrix like this. A1, A2, B1, B2. Then it is an orthogonal matrix only if A1 square plus A2 square is equals to 1. B1 square plus B2 square is equals to 1. And A1, B1, A2, B2. This is going to be 0. If these conditions are going to satisfy, then we would be able to say that it is going to be an orthogonal matrix. Similarly, if we are having 3 cross 3, A1, A2, A3, we have B1, B2, B3, we have C1, C2, C3. Then for orthogonal matrix, you would be having A1 square plus A2 square plus A3 square is 1. B1 square, B2 square, B3 square is 1. C1 square, C2 square, C3 square is 1. Then A1, B1, A2, B2, A3, B3 is equals to 0. Similarly, B1, C1, B2, C2, B3, C3. Rajkumar, are you asking about the question? Are you asking about the question? The values are not wrong, yaar. We all have calculated. Are you asking about this question? Please tell me, Rajkumar, are you asking about this question, what we have done in front of you? This question are you talking about? This question are you talking about? Please tell me. This question are you talking about, Rajkumar? So here, what is the mistake you see? What is the mistake you feel? Tell me. There is no mistake. All of us, we have done this. First of all, we find out the determinant, which is coming out to be 1. Then we have found out here we are going row wise, which is written here column wise. Okay, when you are talking about the 6, you can see this is going to be -1. Okay, 6 will be coming from here, na? It is 2 into 0, minus 3 into 2 is 6. It is correct only. You can see 2 into 0 is 0, minus 3 into minus 2 is 6. 6 only it is. Clear? Rajkumar, I feel you are doing some calculation mistake because everybody cannot be wrong, na? In the class, everybody have done the calculation. Clear, Rajkumar, please tell me. And there are 2 ones. I don't know which one you are talking about. If you are talking about this one, 0 into 0 minus 1 into 1, 1 into minus 1, it will be plus 1 only. That is correct. If you are talking about the second one, it is coming from here. This is going to be 1 into 1 only. You can see that. Where is minus 3? I have not written minus. This is, if you're talking about this, minus 2 into 3. Minus 2 into 3 is minus 6. Sorry, 2 into 0, minus of 3 into minus 2. Plus 6. Fine. Moving further, guys. Sorry for the delay in this. Okay, guys. So I feel everybody understood the orthogonal matrix concept. Now solve this question on that. This is the question. You need to find out the value of x. And it is mentioned that M transpose is M inverse. It means this is the orthogonal matrix. This is the orthogonal matrix. You need to find out the value of x. Just try to solve it, guys. After that, we are entering into the rank of a matrix. Hari Krishnan, what is not clear? Please tell me. What is not clear? Please tell me. Arey bhai, forget about this. They have said this is an orthogonal matrix. Okay, and the matrix is given as 3 by 5, 4 by 5, x and 3 by 5. This is the matrix given, and they are asking you to find out x. They are asking you to find out x. Now is it clear? They are saying this is orthogonal matrix because I just told you कि in orthogonal matrix the condition is it is a square matrix. A transpose is A inverse and A into A transpose is identity matrix. These are the conditions. And here if the elements are A1, A2, B1, B2, A1 का square plus A2 का square is 1, B1 का square plus B2 का square is 1 and A1, B1 plus A2, B2 is 0. These are the condition needs to be satisfied. Okay, and then you need to solve it now. Here, when you will apply the condition A1 ka square plus A2 ka square is 1, that is already both the elements are known to you, you can check it. B1 ka square, B2 ka square is equals to 1. What is that? X ka square plus 3 ka square is 9, 5 ka square is 25 is equals to 1. You would be getting x as plus minus 4 by 5. Here we have doubt whether plus 4 by 5 or minus 4 by 5. So for that we need to go for the second condition. That is nothing but A1, A2. Sorry, A1, B1, B2, A2 is equals to 0. So A1, 3 by 5x plus this is 12 by 25. When you will put it 0, x will be coming out to be minus 4 by 5. So minus 4 by 5 is correct. Is it clear for everyone or not? Please tell me that. Is it clear for everyone or not? Please tell me that. Is it clear for everyone or not? Please tell me that, guys. Everybody understood or not? Moving to the third part, rank of a matrix. Moving to the third part, rank of a matrix. Rank of a matrix. Very important topic. It is also required in the solution for system of linear equation. The most important topic of the chapter for the gate we are now going to enter into. And that is, when we are talking about the rank, first of all, let us understand the rank. Okay. Okay. Before we go into rank, first let us talk about the elementary transformation. So when we are talking about the elementary transformation, they are like this. We are going to convert one row with the other row. We are going to operate that some row is multiplied with some number. We are going to operate this type of operation. So whenever you do this type of operation, if you are talking about matrix, yes, it will change. Determinant, yes, it will change. But there is something called as rank, which do not change by these elementary transformation. So rank is going to be unchanged while these elementary transformation. This is a very, very important thing. Similarly, when you go for these column operations, then also, my dear, whatever column operation you do, it is not going to affect the rank. So elementary transformations are not affecting the rank of a matrix. That is the first thing. We have not seen till now what is the rank. Okay. So elementary operations do not change the rank of a matrix. We will see what is rank. Okay. We will see what is rank. Submatrix, you already know. A part of a matrix is said to be submatrix. Then, my dear, square submatrix also, you know, we have already seen that. So when we are talking about minor, that also we have understood what is minor. Okay. So now, my dear, let us say, if you are going to talk about the rank, now I am going to start with this. First of all, let us say we have a 3 cross 3 matrix. A11, A12, A13, A21, A22, A23, A31, A32, A33. So my dear, first of all, if you are talking about the rank, you would be finding out the determinant of this 3 cross 3. If it is coming out to be non-zero, you would be saying the rank of matrix A is 3. Rank of matrix A is 3. There is no problem. But my dear, let us say if A, determinant 3 cross 3, is coming out to be 0, it means the matrix is a singular matrix. For such case, you would be going for the other square submatrices. First of all, whenever we are finding out the rank, we always consider a square submatrix, because for that we are going to calculate the determinant. Determinant is possible only for a square matrix. So we would be going for all the possible arrangement. You may check this square determinant. 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 Likewise, you can check any 4 elements. You can also take 2 element here, 2 element here. And you would be checking this 2 by 2. Let us say A11, A13, A21, A23. And let us say any of all these 2 cross 3 determinant is coming out to be non-zero. Let us say any of 2 cross 2 determinant is coming out to be non-zero. Then I would be saying rank of A is going to be 2. But let us say if all 2 cross 2 determinant of square submatrix are also coming out to be 0, then I would be checking that 1 by 1 matrix. Means if any of the element is non-zero, I would be saying the rank is 1. So the point is, whenever we are talking about the rank, we need to check like this. This is hit and trial, but we have better methods also. But I wanted to tell you what is the rank actually. So when we are going to define the rank, if we are going to have a square submatrix, the highest order square submatrix, non-zero, will be giving you the rank of the matrix. Okay, this is how the rank is going to be defined. So if we are going to have, let us say this, first of all, it is mentioned already, we have already discussed. Let us say this is a matrix. If we have a 4 cross 3 matrix, Can you tell me what is the maximum square submatrix order possible? If it is a 4 cross 3 matrix, what is the maximum square submatrix order is possible? Square submatrix means you can get a matrix out of that which would be square. What would be the maximum order of that? You can get minimum of 4 and 3. It would be minimum of 4 and 3. Minimum of 4 and 3 is 3. So first 3 cross 3 square submatrix will be possible. So guys, I feel once again to motivate you, Abhinav sir is there in front of us. Sir please आइए, थोड़ा motivate करिए बच्चों को. Sir आइए, कोई बात नहीं, मैं बता दूंगा ये. So guys, sir is always coming to motivate you. अभी comment section में थे, अभी आपके सामने है, देखो.
Echo someone Abhinav is also there.
Yes.
Correct answer है उसका. अभिनव जो आंसर दे उसको सही कर, अभिनव जो आंसर दे उसको सही कर दो.
सही है सर वैसे वो.
अच्छा सर, हाय, हेलो एवरीवन गाइस. डॉन सर, गुड मॉर्निंग. सर ये आई वाज मैं स्क्रिबल पैड कर रहा हूँ. यू सब्सक्राइब और मैं उसके बाद भी आप सही नहीं समझे, फिर मैंने लिखना ही छोड़ दिया. मैं ड्राइविंग कर रहा था.
तो
मैं कह रहा था स्क्रिबल पैड का सेशन कब लेंगे.
बाद में बोल दिया था.
अच्छा कब? नहीं, बाद में आपने बोल दिया था. आपने बोला कि लेंगे. मैंने पूछा था स्क्रिबल पैड का सेशन कब होगा. व्हेन विल बी द स्क्रिबल.
अच्छा, आप पूछ रहे थे.
और आप स्क्रिबल को जल्दी से यूर सब्सक्राइब. फिर से मैं लिख रहा हूँ सब्सक्राइब. जो स्क्रिबल पैड का कब लेना है?
कर लेते सर आज ही. आज रात में देख लेते हैं.
5 PM नहीं, 5 तो आपका 4:30 तो आपका है.
ये 9 बजे के बाद ही हो पाएगा सर.
है क्यों? 5:30
वर्कशॉप
तो 7:30 है.
अच्छा, बीच में भी थोड़ा तो छोड़ो, गैप तो दो.
स्क्रिबल पैड में 20 मिनट्स का है.
चलो कर लेंगे, 6 बजे कर लेते हैं.
विल इन्फॉर्म, मतलब स्टूडेंट्स इन्फॉर्म कर लेंगे. 2 legends in 1 frame. Only 1 legend, yes. Only me. सारे ultra legend.
सही है सर.
Okay. Good morning, sir. Maths, the order of the greatest submatrix in the matrix.
Rank is going on, sir.
सर मैं अपना बीटेक का बताऊं? नहीं, मेरे को आता नहीं है. मेरे को नहीं आता मैट्रिक्स. ऐसा कुछ करते थे, मतलब बहुत सारे तरीके होते थे. एक में यहाँ पे कुछ नंबर आ जाएगा. ये कितने का है?
-4 को
3 into 4 तो मेरे को आता ही नहीं है. स्क्वायर का कुछ ऐसा, मे बी मेरे को आई एम रिमेम्बरिंग ऑफ 10 years बैक. ऐसा और ऐसा.
हाँ
ऐसा
रो इक्लियन फॉर्म.
जितने नॉन जीरो पता नहीं क्या क्या.
वही है सर, वही बस वही चल रहा है सर. Okay guys, so this is about the rank we are talking about. So रो इक्लियन फॉर्म की अभी बात करेंगे हम, जैसा अभी सर बता रहे थे. ठीक है, आप पढ़ाना चाहेंगे रो इक्लियन?
मेरे को आता नहीं सर.
ओके सर. Fine guys. So guys, this is about the maximum square submatrix order possible is 3 cross 3. So when we are talking about the order, the maximum order of this matrix can be 3. We cannot have a order more than 3 for this matrix. That was the point I wanted to tell you here. Okay. Then my dear, we are talking about. इसके बाद ही क्लास के बाद
एक बार आपने बीच में बोला 1 बजे तक चलेगी, आप खा लो तब तक. मैं नहीं, तो मैं प्रोबेबिलिटी करता हूं.
कंटिन्यूटी जरूरी. Okay guys, so if we are having this matrix, you know that when we are having this matrix, as all the elements of one row is 0, so 3 by 3 determinant is going to be 0. Obviously rank is going to be less than 3. Okay, now we would be checking the 2 by 2 matrix. Let us say this is going to be 1 into 4, 3 into 2. 4 minus 6 is non-zero, so we can say rank of this matrix is 2. Okay, this is just to give you a rough idea, a vague idea, but now we are going to see the other formats by which we will be calculating this. Okay, fine guys. So moving further. So as we have already seen, if all the minors of order r plus 1 are 0 and at least one minor of order r is non-zero, then the rank of the matrix is denoted by this. Already we have discussed, this is the definition written. Okay, we need not to go into that. Now my dear, if we are going to have, let us say this is a square submatrix 1 2 3 4 1 2 3 4. So if here someone is asking you what is the maximum rank possible, you would be saying the maximum rank possible is 4. So it would be less than or equals to 4. Now my dear, I would like to tell you, before we find out the rank, there are two ways. One is this vague way which we have seen. The second way to find out the rank is to go with the row Euclidean form. Okay, we are going to enter into that. But there are some properties also to find out. Like let us say if we have a row matrix. So if we have a row matrix, can you tell me what can be the rank of this row matrix? What can be the rank of this row matrix? It is either 1 or 0. These two are the possibilities. If any of the element is non-zero, it is going to be 1. But if all the elements are 0, either we will call it 0 or we will call it as not defined. Okay, so 0 or not defined both can be in the option. So I would like to tell you, for a row matrix which is not having all the elements 0, the rank of A would be going to be 1 only. Okay, similarly for column matrix, if you see this row matrix, the rank is going to be 0. This is going to be 0. When we have a column matrix, my dear, you can see here also the rank of A would be either 1 or 0. If all the elements are non-zero, rank is going to be 1. Okay, here 1 is the right answer. Similarly, my dear, here we have all the zeros, so rank of A would be 0. So you got a property of rank that for row matrix, for column matrix, rank would be either 1 or 0. That is the first point. Okay. Then we are going to have next. A is 1 to 3, B is 3 to 1. Here you can see 1 into 3, 3 into 1. This is a row matrix and a column matrix. If you are going to get a product of row and column matrix, you know that the number of column here would be the number of row here. So overall the matrix would be coming of 1 cross 1. So once again here also the rank would be either 1 or 0. So when you will be multiplying 1 into 3, 2 into 2, 3 into 1. So 3 plus 4 plus 3, it is going to be 10, and it is going to be rank of AB is going to be 1. So what we have concluded till now, the rank of row matrix 0 or 1, rank of column matrix 0 or 1, rank of the product of a row and column matrix 0 or 1. We will say 1 if any element is non-zero. It will be 0 if all the elements are 0. Is it clear? So guys, next we are going to have this. If we have this is 1, this is B. Tell me the rank of AB. Tell me the rank of AB. After that we will be entering into the good format of row Euclidean form and all. After that we will go into system of linear equation. Very good. Here rank would be coming out to be 0 because the product of matrix AB would be coming out to be 0. So rank AB is either not defined or 0. Okay guys. So now for identity matrix, the rank is always the order. Okay. If we have an identity matrix, the rank is equals to the order of the matrix. So here we can say rank would be 3. Here we can say rank would be 2. So row of IN is going to be N. Is it clear for everyone? Yes. So we are going to say the rank of this matrix would be 3. Okay. If we have this scalar matrix, so this is a 3 cross 3 matrix. So the rank of a scalar matrix is also equals to the order of the matrix. So if we have a n cross n scalar matrix, the rank would be 3 only. Is it clear for everyone? Yes. So next, my dear, we can have the methods to calculate. So guys, whenever we are talking to find out the rank, one was the basic method which we were discussing till now. Second is the row Euclidean form, which we are going to understand now, and 99% time you would be having the question from this only. Only 1% you will see the basic cases which we have done right now. So now we are going to see what is the row Euclidean form. Now we are going to see what is row Euclidean form. So when we are talking about the row Euclidean form, the very first condition is whenever we are going from top to bottom, the number of zeros should increase. And number of zeros are not the total number of zeros. Number of zero before first non-zero element should increase. Second condition is if any row is having all the elements as 0, that should be at the last. So if you see this, one row is having all the elements 0, that is at the last. And when you are going from top to bottom, yes, number of zeros are increasing. So it is in row Euclidean form for sure. When we are talking about this, there is no row with the all 0 elements. So we need not to check that condition. When you are going from top to bottom, here there is 1 0, here there are 2 0 before non-zero element. Yes, it is row Euclidean form. This is row Euclidean form. Yes, this is row Euclidean form. Yes. Can you tell me here, is this in row Euclidean form or not? Please tell me. Akshara, Lemon, Shreyas, Danesh, everybody please tell me, this is in row Euclidean form or not? Please tell me. Rohan, everybody, Saurabh, This is not in row echelon form. Why? Because here also 3 zeros, here also 3 zeros. When we are going from top to bottom, the number of zeros should increase. If they are not increasing, we would be saying it is not in the row echelon form. Okay, so for that we need to make it in the row echelon form. We would be going for elementary row operation, because you know, by going for elementary row operation, rank of the matrix do not change. So we would be going for R3 operated as R3 minus 2R2. When you would be going for that, you can make this matrix as 0, 1, 2, 3, 0, 0, 0, 1 and 0, 0, 0, 0. Now you can see that all the elements are 0. This is 3 zeros, these are 4 zeros. This is in row echelon form. So if it is not in row echelon form, we have to convert it, because once we are having the matrix in the row echelon form, then only we can tell what would be the rank of the matrix. Okay. Now you can see this one. Can you tell me this one is in row echelon form or not? Can you tell me this is in row echelon form or not? Yes, 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 yes. Please tell me. This is in row echelon form or not? This is also not in row echelon form, because this all 0 row is at the top. When we go from top to bottom, number of zeros should increase. So we would be going for the row operation and we would be interchanging these two rows. And when you would be going for interchanging, it would be coming out to be, let us say you are first of all interchanging these two and then these two. Then you would be having 0, 0, 2, 1, 0, 0, 0, 3, 0, 0, 0, 0. So this is how we would be converting this matrix into the row echelon form. Okay, that is only possible. If we are going like that, we can convert it into row echelon form. So guys, now if we have this, can you tell me? Okay, now I feel let us start some questions. With that we will be understanding better. Okay, with that we would be understanding better. Let us say this is the question in front of you. This is the question in front of you. So just by looking at that, tell me, is this in row echelon form or not? Tell me, is this in row echelon form or not? You can see number of zeros increasing. There is no row with all the zeros. Now, my dear, whenever you have this, you just need to see the number of rows with non-zero elements. This row is having all the elements non-zero. This is having 2 elements non-zero. This is having 1 element non-zero. So we would be saying the rank of A is going to be 3. So it is nothing but the rank of A is number of non-zero rows. Number of non-zero rows of a row echelon form of matrix. Is it clear, guys? This is how we are going to define the rank with the help of row echelon form. Is it clear, guys? So here rank would be 3 straight away. Everybody understood? Yes. Everybody understood? Very good. Everybody understood? Very good. Very good, guys. बहुत ही बढ़िया. So guys, now we are having this case. Can we try for the rank here? 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 Yes. Try to find out then. Try to find out then. Try to find out then. Yes, yes, yes. This is not in the row echelon form. We need to convert it. So what operations you can go for? You can go for R3 minus R1. You can go for R2 minus R1. You can go for these operations to make it in row echelon form first of all. When you would be going for that, first row will be 1, 1, 1. Second row will be 1 minus 1 is 0. Minus 1 will be minus 2. 1 minus 1 will be 0. And then you can have 0, 0, 0. Now, my dear, you can see this row is 0. So rank of A is going to be not 3. And now it is in row echelon form. Number of zeros are increasing. Here all the zeros are there. So rank of A would be 2. Everybody is clear about this or not? Very good, Banu Prakash. Very good, Abhi. Very good, Mayank. Very good, Sake. Wonderful, Kuldeep. बहुत ही बढ़िया, शानदार, guys. So this is how we can find out the rank. We will be going for the system of linear equation also after this. Let us see the next case. Tell me the rank of this. Tell me the rank of this. First of all, we need to understand how to get the rank. Then only we can understand the system of linear equation. Tell me the rank for this, guys. Tell me the rank for this. 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 Yes, 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 everybody. Everybody is saying the rank is 2 once again. Why? Because you can see that we can go for the operation R3 operated R3 minus 2 times of R1. When we would be going for that, you know that it is going to be 1, 1, 0. It is going to be 0, 1, 0. It is going to be 0, 0, 0. Once again, you can say row echelon form is coming. So rank of the matrix A is going to be 2. Very good, guys. Everybody have done it nicely. Moving to the next case, guys. This is once again a 3 cross 3 matrix. Find out the rank for this. Find out the rank for this. Find out the rank for this. By looking at this, you can see there is no other conversion possible. It is already in row echelon form. Yes or not? Yes or not? Please tell me again. Yes or not? Yes or not? Please tell me that. Yes, rank of A would be coming out to be 3. Here rank of A would be coming out to be 3. Guys, this is the last question. After that, we will enter into the system of linear equation. This is the last question. After that, we will enter into system of linear equation. This is the last question. After this, we will enter into system of linear equation. You need to tell what is the rank of this. What is the rank for this? So first of all, this is not in row echelon form. This is not in row echelon form. Everybody. First of all, this is the matrix with 3 rows and 4 columns. This is the matrix with 3 rows and 4 columns. So definitely its rank cannot be more than 3. And to convert it into row echelon form, we need to operate the operations like R3 would be operated. R3 plus 2 times of R1. Okay. When we would be going for that and we would be operating R2. It is going to be 2R2 minus 5R1. So when we would be going for these operation, we would be getting it what? 2, 3, 4 minus 1 is going to be as it is. When you would be operating on R2, it is going to be 2. 10 minus 10 will be 0. Then we are going to have 2R2. 2 into 2, 4 minus 15. 4 minus 15 is minus 11. Then we are going to have this is 0. Okay, when you are going to do this, you would be having this is going to be 0, this is going to be minus 5, it is minus 20. Then minus 1 into minus 5, 1, it is going to be that minus 1, minus 2 and plus 5, it is going to be plus 3. And when you would be going for this, this is going to be 0 and you would be having 2R1, 2 into 3 is 6, 6 plus 5 is 11. Then we are going to have this to be 12, okay. So it is going to be 12. This is going to be 4 into 2, 8. 4 into 2, 8. 8 and 12 is 20. And then you can say one more thing. You can see one more thing. It is going to be R3 plus 2R1. Minus 1. Minus 1. It is going to be minus 3. This is the condition we are having. Now we can operate R3. R3 plus R2. I feel you would be getting 2, 3, 4 minus 1. 0 minus 11 minus 23 0 0 0 0. हल्के में नहीं लेना है भैया, हल्के में नहीं लेना है. क्या आ रहा है रैंक? What you are getting as the rank? Lightly नहीं लेना है. What you are getting as the rank? Rank is coming out to be 2. All of you have said previously that it is going to be 3. Okay, that's why to check you guys I have given this question. Don't take it lightly भैया, गलती हो जाएगी. Rank is going to be 2 here. Wonderful, guys. Rank is going to be 2 here. Wonderful. Is it clear? Yes. ऐसे ही खेलते हैं गेट वाले भैया. हमें भी खेलना पड़ेगा इसलिए. Okay, guys. Now we are entering into the system of linear equation. Okay, because these properties we have already discussed. Okay. Now, my dear, we are going to enter into the system of linear equation. Okay, before that, there is one more thing. The number of 0 rows is also known as nullity. Number of 0 rows is also known as nullity. Now, my dear, we are going to have a wonderful thing. Okay, I feel system of linear equation is missing here. Okay, no issues. We are going for this. When we are talking about the system of linear equation, when we are talking about the system of linear equations, when we are talking about system of linear equations. So guys, I already told you if number of variables are less, we can very easily solve it. But when we have more number of variables, then what is the case? There are two types of systems possible. First type of system is when we are going to write the matrix as AX is equals to 0. Second is said to be when we are writing AX is equals to B. So when we are talking about A into X as 0, it is said to be homogeneous system of equation. It is said to be homogeneous system of equation. And when we are going to have AX is equals to B, what do you mean by that? Here let us say the equation is A11X1. Then we have plus A12X2. Then we have A13X3 is equals to B1. Let us say this. Then we have A21X1, A22X2. Then we have A23X3 is equals to B2. We are having A31X1, A32X2, then A33X3. It is equals to B3. So guys, if we are having these three equations, and all B1, B2, B3 are not equals to 0, all B1, B2, B3 are not equals to 0, then we call it as a non-homogeneous system of equation. We call it as a non-homogeneous system of equation. And if we are having right hand side, all B1, B2, B3 are 0. If all B1, B2, B3 are 0, all, then we will be calling it as homogeneous system of linear equations. So the point is, you are already aware how to find out the solution if we are given the equation, if the variables are 2 or 3. How? Like let us say we have a line, we have an equation 2x plus 3y is equals to 7 and 3x plus y is equals to 6. You would be solving these two equations. And after solving, if you are getting these two lines to be coming like that, and they are going to be intersecting at one point, which is nothing but x comma y, you would be calling this solution to be a unique solution. You would be calling this solution to be a unique solution. Yes or no? And if these two are coming like the parallel lines, like this is one line, this is another line, then you know both the lines are intersecting at all the points. So for this case, we would be saying infinitely many solution. Infinitely many solution. And let us say if these two lines are coming out to be parallel to each other, then we are going to say there is no solution. Then we are going to say there is no solution. Then we are going to say there is no solution. Then we are going to say there is no solution. So guys, if we are getting the solution, maybe it is unique or infinitely many, we are calling such system of equation to be consistent. We are calling such system of equation to be consistent. And if we are getting no solution, we are going to get it as inconsistent. So I would like to tell you, like we have seen the two systems of equation, whenever we are having homogeneous system of equation, it is always going to be consistent. It is always going to be consistent. It is never going to be inconsistent. So here, my dear, we are always going to have consistent. Here it can be consistent also. It can be inconsistent also. It can be inconsistent also. Now, my dear, if we are going to have infinitely many solution, we call it as non-trivial solution. And if we are going to get unique solution, we call it as trivial solution. Is it clear for everyone or not? Please tell me that. Then I will tell you how rank will be helping us to find out that solution. Yes, having solution means a consistent. Yes, you are correct, dear. You are correct, dear. But this is the language of mathematics which I am using. Is it clear for everyone or not? Please tell me that. Is it clear for everyone or not? Please tell me that. So first of all, we would be talking about the non-homogeneous system of equation. First of all, we would be talking about the non-homogeneous system of equation. So when we are talking about non-homogeneous system of equation, non-homogeneous system of equation. Let us say we are given the equation like a1x1, a2x2, a3x3 is equals to b1. Okay. Let us say we have then a11, a12, a13. Okay. Then we have A21x1, A22x2, A23x3 is equals to B2. Then we can write A31x1 plus A32x2. बड़े थक तो नहीं गए भैया, थक तो नहीं गए हो ना? Just we are reaching towards the target slowly, not fastly. Okay. So if we have these system of equation, so guys, everybody is happy with this series, na? Everybody wants all the topics like that we are going to complete. Don't worry, within next 15-20 minutes this will be over. 2-3 questions we will see. Now we are going to have, we can also write this equation as A11, A12. What you would be doing, you would be writing like this: A21, A22, A23, A31, A32, A33. If you are writing it like this, this is going to be a matrix A, because we can write this system of equation as AX is equals to B. And I feel everybody understand this. Whenever I am writing a matrix like this, this is said to be matrix A. Matrix A is nothing but X1, X2, X3. Similarly, matrix B is nothing but B1, B2, B3. So this is going to be individual matrix. But whenever, okay. But whenever, हाँ, पृथ्वी इसके बाद आइगन वैल्यू और आइगन वेक्टर देखेंगे. But whenever we are going to talk about this, like we have written, X is this, B is this, okay. Whenever we are going to talk about this AX is equals to B, I would like to tell you one thing which is very, very important here, that all these elements I have written, we would be defining a special type of matrix which is said to be augmented matrix. Now what is this augmented matrix? Augmented matrix is defined as matrix A, B. Like I can write this, first of all write all the elements of A, like A11, A12, A13, A21, A22, A23, A31, A32, A33, and you can make a line here, or you can write like this 2 dots here, and here you write B1, B2, B3. Then this matrix is said to be the augmented matrix. This matrix is said to be the augmented matrix. This matrix is said to be the augmented matrix. Is it clear, guys? So when we are having this matrix as augmented matrix, you are already having this matrix A. So whenever you are going to find out the rank of A oblique B, if it is coming out to be equals to rank of A, and it is coming out to be equals to the number of variables, can you tell me what kind of solutions we are going to get? This is the first condition. Can you tell me what kind of solution we are going to get? Can you tell me what kind of solution we are going to get? देखते हैं कितने लोगों को याद है. Very good, Shobik. Can you tell me what kind of solution here we are going to get? If rank of A oblique B is equals to rank of A, that is equals to number of variable, you would be getting the unique or trivial solution. Very good, guys. Very good, guys. But if we are going to have rank of A augmented matrix, rank of A, but that is going to be less than the number of variables, then my dear, you would be calling the solution to be what? You would be saying it is going to be what? It is going to be what? Infinitely many solution, non-trivial solution. And if, my dear, by chance you are getting rank of A augmented B is not equals to rank of A, then, my dear, this condition you would be saying as no solution. Please tell me, this is inconsistent system of equation. Is it clear for everyone or not? Please tell me that. Is it clear for everyone or not? Please tell me that. Is it clear for everyone or not? Please tell me that. Is it clear for everyone or not? Please tell me that. Tell me, guys. Everybody. Yes. Down नहीं जाना है. यही तो सबसे important topic है भाई. Wonderful, guys. So, guys, now we are going to see 2 to 3 questions on this. Okay. And then we will enter into the next topic. So, guys, now, as I feel, because of some, I feel mistake, those questions I am not able to find. So that is why I am writing the statement in front of you. Okay. So we are having a question. I am having some previous year's question with me. Let me write the question. Okay, this question is saying like this, like it is x plus 2y plus z is equals to 6. This is one equation. Then I have 2x plus y plus 2z is equals to 6, and the third is x plus y plus z is equals to 5. And you need to tell what is the condition for this equation, whether it is having a unique solution, the system of linear equation, or it is inconsistent. This is a previous year question. Infinitely many solution. D. None of these. Can you tell me? Can you solve it? Can you try by yourself? Can you try by yourself? We would be doing 3 questions like that. Okay, and then we will enter into the next topic. Solve it, guys. Solve it, guys. थक गए हो तो बता देना, क्योंकि अगले वाले जो 2 टॉपिक्स है वो बहुत छोटे हैं. अगर आप कहेंगे तो हम आइगन वैल्यू, आइगन वेक्टर उसके साथ डिस्कस कर लेंगे, क्योंकि न्यूमेरिकल मेथड छोटा सा टॉपिक है, 1 घंटे का. तो इफ यू वांट वी कैन आल्सो ऐड दिस टॉपिक देयर, इफ देयर इज नो प्रॉब्लम. इफ यू आर फाइंडिंग कि सर थक गए आज, प्लीज टेल मी. First solve this question. First solve this question. Solve it, guys. Solve it, guys. Solve it. Solve it. Solve it. Solve it. Solve it. Yes, this is a non-homogeneous system of equation. That's correct. That's correct. It is non-homogeneous system of equation. Now you need to write the augmented matrix, which is 1, 2, 1, 2, 1, 2, 1, 1, 1. And you can check the rank of both here only. Okay. Like this. Now you need to perform the operations. You know, I need to increase the number of zeros. Very easily you can identify R2 will be operated as R2 minus 2R1. And R3 will be operated as R3 minus R1. Just operate it. When you would be operating it, 1, 2, 1, 6. You are saying R2 minus 2R1. It would be 0. 1 minus 4 is minus 3. 2 minus 2 is 0. 6 minus 12 is minus 6. R3 minus R1. 1 minus 1, 0. 1 minus 2 is minus 1. 1 minus 1 is 0. 5 minus 6 is minus 1. Okay, this is the case. Now, my dear, I can operate R3 operating R3 minus R2 by 3. Even I would like to say this. The matrix would be coming out to be 1, 2, 1, 6. There is no change. It is going to be 0, minus 3, 0, minus 6. R3 is operated minus R2 by 3. So 0. Minus R2 by 3, it will be 0. It will be 0. And minus 1 plus 2 will be plus 1. Yes. If you see this, just observe guys, just observe this matrix. This is matrix A. So if you would be observing this, you can say rank of A is nothing but 2. If you observe the entire matrix, rank of AB is 3. You can see both are not equal, so answer will be inconsistent. This is the previous year question of GATE. Everybody understood? Please tell me that. Everybody understood? Please tell me that. Everybody understood? Please tell me that. Shall we do one more question? Are we ready for that? Shall we do one more question? Are we ready for that? Next question, guys. Next question is in front of you. If anybody have any doubt, you can stop me. Next question is 2x plus y plus 3z is equals to 5. Then we have 3x plus z is equals to minus 4. Then we have x plus 2y plus 5z is equals to 14. And this time I am asking the same thing in front of you. Unique solution. It is infinitely many solution. It is no solution. Or homogeneous system of equation. Solve this question, guys. Now this time I am expecting the answer from you guys only, and I hope everybody would be giving the right answer. One more question after that we will do. One more question after that we will do. Solve it, guys. Solve it, solve it, solve it. I am once again telling you on 26th of January, celebrate the Republic Day with us. 75 questions will be there in front of you. 75 questions. Aptitude and mathematics, 2 sessions separately. One session will be in the morning time, one will be in the evening time. Maths will be in the evening time. So be ready. I want all of you to see there. And guys, I will be covering everything. Calculus also will be covered for you. Don't worry. Okay. I changed topic because as on 26th class is not there and many students, they are not going to cover all the topics. So matrix is easier one. So I have taken before so that if anybody is not interested in calculus, at least he can secure 2 marks from matrix. Show week 26 January, we would be having on app. Okay. If possible, we can have a small topic like numerical method on the YouTube, if possible, that we will be informing you. But this is on app. Because in app, we will be having quiz mode. We can see how many marks you are scoring. Okay. I feel many of you have given the answer infinitely many, which is correct answer. So guys, I would be going for the matrix now. I would be going for the matrix now. I would be going for the matrix now. Matrix would be 2, 1, 3, 5. 3, 0, 1, minus 4. 1, 2, 5, 14. This is augmented matrix, you know that. And when we are talking about this, you are going to say first of all the operation. R3 minus 1 by 2 of R1. Okay, is it clear? Everybody got the B answer? Everybody got the B answer? Please tell me. Yes. Second operation is R2 minus 3 by 2 R1. When I would be going for this operation, भाई वैसे प्लान तो नहीं था, कहोगे तो करा देंगे, ठीक है, प्लान तो नहीं था, कहोगे तो करा देंगे AMGM भी. So when we are talking about this 2, 1, 3, 5. So when we are going for R2 minus 3 by 2 R1, it would be 0. Okay, I am writing directly what I would be getting because this I have solved for you. Minus 3 by 2, minus 7 by 2 and minus 23 by 2. And here we would be getting 0 plus 3 by 2 plus 7 by 2 plus 23 by 2. You would be going for R3 plus R2. This will give you the third row to be completely 0. 2, 1, 3, 5. 0 minus 3 by 2 minus 7 by 2 minus 23 by 2. 0, 0, 0, 0. So you can see here, are we getting the same? Here you can see rank of A is equal to rank of A. But it is less than the number of variables. So answer for this is infinitely many solution. Is it clear? Okay, Rohan. Surely we will do for that. Okay, I feel everybody have done this question. Everybody have done this question. Is it clear for everyone? Everybody have done this question. Is it clear for everyone? Please tell me that. Please tell me that, guys. Please tell me that. Is it clear for everyone? Please tell me that. So I would like to tell you, whenever you have homogeneous system of equation, whenever you have homogeneous system of equation, then also it is always consistent. It is always consistent. Then my dear, you would be having two types of solution. One is trivial, other is non-trivial. I would like to tell you, whenever we say the trivial solution here trivial solution is also said to be the zero solution. And non-trivial solution is also said to be non-zero solution. Okay, and whenever we are going to get determinant of A is equals to 0, it is going to be non-trivial. Okay, it is going to be non-trivial. And whenever we are going to have determinant of A is non-zero, we are going to have the trivial solution. So I feel this is the case of homogeneous, but for gate, non-homogeneous system of equation is more important. So with this, we have completed the system of linear equation. So guys, I feel 2.5 hours have been over. So I feel you guys also be थोड़ा सा थक गए होंगे. So shall we do like that कि when we are meeting for the next topic, numerical method, that is a small topic, 1 hour. So with that, we add eigenvalue and eigenvector because that will be making us efficient also. And as we are going to complete the course, you are there with us, तो क्या फर्क पड़ता है? Is it clear? Is it clear? Everybody is okay? So shall we cover eigenvalue, eigenvector? Because मुझे लग रहा है आप भी थक गए हैं. Break देने से अच्छा है कि we would be going for that. Okay, Faninder, don't worry. I am going to cover each and everything. Efficiency के साथ करेंगे तो मजा आएगा. ठीक है? ओके, एफिशिएंसी के साथ करेंगे मजा आएगा. अभी जैसे लग रहा है ना कि आधे मर गए, तो वो नहीं होना चाहिए. ब्रेक नहीं रखते यार. आधे पौने घंटे की बात है, पौने घंटे के लिए ब्रेक में तो खत्म हो जाएगा मामला. ओके, इज इट क्लियर? क्योंकि मेरे को वैसे कोई दिक्कत नहीं है, आई एम हैविंग द टॉपिक, बट मैं चाहता हूं कि अच्छे से वो सारी चीजें जैसे हम अच्छे से कर रहे हैं. इज इट क्लियर? सो यू कैन सी आई एम हैविंग दिस थिंग्स. आई एम हैविंग ऑल द प्रॉपर्टीज ऑफ आइगन वैल्यूज, आइगन वेक्टर लाइक दैट. Okay, so I am telling you that with the numerical methods, and don't worry, if you guys are ready on 26th of January, we can keep this session on 26th January also. Will you be able to attend both the session on YouTube and app? We can go for both also. We were doing it on app for practice. If you are ready, we can go on 26th January also. Is it clear for everyone? Okay, then don't worry, we would be meeting. यार ब्रेक वाला सिस्टम मत रखो, क्योंकि मेरी इसके बाद भी क्लास है. ठीक है, मैं ब्रेक दे के जाऊंगा तो फिर मेरी दूसरी क्लास अफेक्ट हो जाएगी. भानु प्रकाश, if that is the case, don't worry, I would be informing you first only. Okay, I would be informing you first only. First, we will cover that only, eigenvalue and vector. Then we will start, because eigenvalues and eigenvector are common for everyone. So first we would be going for that only. Okay? Yes. So first we would be going for eigenvalues and eigenvectors. And then we would be going for numerical methods. So we will go in that way so that every student can attend. उदय, मॉक टेस्ट में कम मार्क्स आ रहे हैं तो आपको ये देखना है कि आप गलती कहां कर रहे हो. जहां गलती कर रहे हो उसको आइडेंटिफाई करो, उसको करेक्ट करो. ठीक है? अगर वो कैलकुलेशन मिस्टेक है तो कैलकुलेटर पे हाथ आजमाओ, 2-3 घंटे कैलकुलेटर पे प्रैक्टिस कर लो. कॉन्सेप्चुअल मिस्टेक है तो वो आप 1-2 दिन में सारी तो करेक्ट नहीं कर सकते. फिर आपको ये देखना चाहिए कि किस लेवल की गलती आप कर रहे हो. आप मुझसे अलग से कनेक्ट हो सकते हैं, मैंने अपना नंबर दिया हुआ है. Abdul, you do one thing. You join my Telegram channel, Mechanical by Dheeraj Sardana. You will be getting there the link of workshop, link of session. You just need to click on the button and the class will open. Yukta, last mock test I feel would be you just put a mail to me. I will be forwarding it to the team. Is it clear? Everybody is happy with this series? Faninder, yes, 13 out of 13 is possible. Who said it is not? It is possible. We say 10 plus just because some question may come out of the box. 1 to 2 questions. For that, everybody would be having the problem. Okay, I feel everybody is happy with this series, and guys, I am very happy to see your love and support. Okay, so I don't want it to extend it much, otherwise I could complete it, because मैं चाहता हूँ efficiency से हो. Complex number, numerical method, they are small topics. There only 1 hour class will be there. So there, if we add that eigenvalue vector, our marks will multiply. So that's why we are going like that. That's great, Bhargav. Fine. So guys, we are going to meet. Prithvi, you join my Telegram channel. There you will get the time of every session. I inform at least 1 day before every session. So why not you join Telegram channel? Join the Telegram channel. There you will get all the details. Okay. Chandrasekhar, next topic would be numerical method and calculus. Okay, now we may be having after 26 every day one math session, because aptitude session is going for 1 hour only. So we would be adding a 1.5 hours mathematics lecture to that to complete calculus, because calculus is a big topic. So that is why I would be requiring 2 lectures for that. Okay, that is why. Mechanical by Dheeraj Sardana is my Telegram channel. Mechanical by Dheeraj Sardana is my Telegram channel. So guys, I would be पृथ्वी यार, आप मेरा 13x13 वाला सेशन देख लो, वहां मैंने बताया है कितने मार्क्स का आता है. अब मान के चलो 4 नंबर का आ जाएगा लगभग कैलकुलस. ओके, fine. So guys, here we are leaving it, and I feel everybody is happy with the series, and we will be meeting once again. Okay, tomorrow aptitude session is there, then day after tomorrow we would be having app, plus I will keep one session for math on the YouTube also. So be ready for that. Okay, we will try to have the session on 26th on YouTube in the night time. The reason behind that is on 26th morning, maybe someone have some plan to watch the parade and all. So we will not affect that. Okay. So goodbye guys, and thanks for your wonderful love and support. Goodbye. शमशाद, कैलकुलस होगा, किसने कहा नहीं होगा? हर एक टॉपिक होगा. कैलकुलस होगा, 26 के बाद होगा कैलकुलस.